Thank you. And it looks like we are broadcasting. Okay. Hi, everybody. It's Tuesday once again already. It seems like every day's Tuesday here for some reason. Tuesday, March 14th, 2017. And we are in the third month of 2017, and the planet is still together. Isn't that amazing? Of course, with what John says, we could only have a couple of weeks left, but I don't know. We'll just have to see and go week by week and day by day as we endure planet Earth, game planet Earth. Okay, wondering what we could do for today. I've got I've got a new toy to show. It was discount day at the dollar store, and all the other broken lab equipment from last week. I'm pretty broke, so all I got is $1.25 to spend. Actually, 2 times that, because I got one for Guy too. I've shown these before, and they're it's a pretty cool tool, actually. What's it called again? It's a sparkling. Jeez, can't believe the name. Sparkling spindle scintillant. Whatever I think that's the French aspect of the sparkling spindle. Basically, it's called the sparkling spindle, right? So the idea is you can twirl it, and it's sort of like a soap bubble in a way. It does different configurations and whatnot. And when you get it, it actually looks like this. Really neat little sphere. But if you look really closely, there's a sphere within the sphere. There's actually 2 of them there. Okay, it's a little hard to see. There, you can see it better once I sort of spin it a little bit. You can see the sphere inside that appears. So you see, like when you do it this way, it's kind of got a bit of a saucer shape before it goes this way. You have to get it just the right speed. Whoops, just went too far there. So just before that. Maybe if I hold it up a little bit. No, it doesn't work that way.
You're having way too much fun.
And then if you you can do other things with it. You can see that bubble effect. Let me see if I can get this right. It's a little like this. Whoa. There you can see 2 bubbles there, sort of interpenetrating, right? And there you can see that other little one inside there. And they separate, and then they come back together as 2 bubbles back into one. And even that one, if I was to hold this one, I guess, and twist the other one here. Not sure if I'm supposed to do this, but you can get 2 out of it. That's one of the configurations. But it pops into that 2 mode right about there. You have to continue twisting it to get that. Otherwise, if you just leave it, it tends to want to... Oh, there it is. But then it pops back into this mode. And depending on the effects of gravity, you can get different configurations. This way or this way, even in between and so on. And this part pulls out a little bit, so you have a little bit of play there in terms of I guess what it can do this way. It wants to find its own position and whatnot. And there's a few other modes which I've forgotten how to do now, actually.
I'm just wondering why you haven't tied a motor to it yet.
Well, now that you brought that up, John, I do have a knife here. And this little end has been a little bit annoying, so let me cut that off. And now I've got a shaft on this. Actually, if I cut it off shorter, that would be better. Let me do that. Now I have a short shaft. And I was hoping I could actually get it hooked up to my my little motor thing here. would be fun. So let's see if I can do that actually. Some light on it. And well, I have to let down the long legs of my tripod here for this one. And let me see if this will, oops, it popped out here. Let me just get it back in. I'm not sure if it'll, yeah, it should fit in this chuck. So bear with me a minute while I try to get the apparatus ready here. I hear the ding-dong bell if somebody's just come in.
Yeah, Mark just got here.
Okay, tighten that up a bit. Oh, cool. Okay. Yeah, okay, let me, I need to lower it a bit because it's still too high. So let me do that. A little bit closer. Maybe better lighting. There we go. Now I gotta hook up the battery to this system here. How did I have that before? Let me see here. Pull these out. Excuse me while I disconnect that terrible buzzer sound in just a minute. I don't have a good connector for the battery. It might be a bit of a pain. What I'll do is I need a little probe. Just bear with me. It's just a temporary glitch in the broadcasting here. Alright, I think that'll work adequately. Now, I'll find my nifty little remote control. And let me see here. I should be able to.
Now, will it go slow enough?
Whoa. Yeah, it's going to be hard to go slow. Okay, I'll see what I can do here. Yeah, it might be a little bit wild, let's say. I think might have to put on the old safety glasses for this, just to be sure. Don't want Rick to go blind for the rest of the workshop. That wouldn't be good.
You're not allowed to bleed.
No bleeding online. It might kick the live stream off. Okay, so I guess it's more or less all system let go. I think my battery might be low, but I'll give it a try here. Oh, I already. Oh, there it is. Well, it's not exactly what I had in mind that way, but oh, that's kind of neat. Quite a wind coming from it. It's a good windmill. A good fan. And away she went. It was heading for my face too. And I've kind of kerfuffled it, it looks like. But it was going actually pretty fast there, amazingly, and it was holding its, holding some sort of structure there for a while, but I would have to sort it out. I don't think it's worth it. Yeah, the shaft actually broke off because it started to vibrate so much. It's not made for high speeds, obviously. Oh well, not every effort can be a cracker jack, as they say. But it was well worth the visuals. So, okay, we'll go back to more sane things. Let's see, whatever that means. Not like it's been too sane before, in many senses. All right, have it pretty much back together here. Well, it was kind of fun, but I don't know if we really proved too much out of that little episode.
Well, we know that Mylar doesn't like high speed.
Well, I'm surprised. I didn't think it would make it over 1,000 RPM, but it went into, instead of just spreading out, which I thought it would do, it seems natural that the centrifugal force would push it out. It actually contracted into kind of a little ball sort of thing. So
Yeah, well, there's a lot of air resistance to that Mylar, so.
yeah, well, again, when it was first starting up, I could feel it blowing quite strongly against my wrist. You know, it was like generating like a little fan. And then when it got into it shrunk and went into the high speed mode, I could hardly feel the air coming from it. So those who are aerodynamically inclined might take those little hints and design some sort of strange flying machine based on those principles. Who knows? Not me. But they are fun. You can actually spend quite a bit of time with that little spinner and its different configurations, because if you look at the double rotating vortex concept that we've seen in different configurations, then that's basically what the little spinning spindle does. Anyway, enough of the spinning spindle. Another little project I've played around a bit this week or whatever, was my sphere here, the 500 milliliter flask, and now I've got a ultrasonic sensor, ultrasonic transducer really, attached to the side, glued onto the side, and I had that on last week, but I hadn't experimented with it. So I hooked that up, the two leads, there's just two leads on it, and I hooked that up to just a regular phono plug. Two ends over here for the phono plug, and I just attached that to the leads on the transducer, and plugged this into my what was I using, the iMic in this case, little iMic adapter that I wouldn't even really need to use that, but it's handy. It's got an in and out, and I can select line or mic for the input sensitivity, and plus it plugs into USB, so it doesn't take up my audio port, which I can use for something else. So I had that plugged in, and getting a reading of the frequency from the transducer, and you can see at the same time I was using the other audio from my computer to go into this amplifier, and the amplifier came out to a speaker that's inside of here. You can't see it too well there. There's the bottom end of it. This is high, very strong tweeter. It's a 350 watt, supposedly 175 watt RMS tweeter. And so I was tweeting this, you might say, with different sounds, everywhere from 4,000 hertz up to about 24,000 hertz. And I was watching at the same time as going through the frequencies from 4,000 to 20,000, roughly 22,000. I'd watch the response from this lead here. And I had a graph kind of thing set up. Maybe I can actually show it in a bit here. I'll get it set up. But the idea is that you get a response, and you can see by the response that this flask, or at least the glass part of it, is resonating. It's actually picking up the sound from inside more than the glass resonating, but it picks up, and you can see by the response how strong this sound is. It can actually be measured in millivolts. So there's certain peaks that happen with this flask. You can see definite points along the frequency spectrum that it resonates at. So the idea would be to find an optimum resonating frequency, preferably a high frequency. In the for this, it should be around in the 12 to 18,000 hertz spectrum, and to try to, I actually found at 8,710 hertz seemed to be the most resonant for this particular setup. But there could be other higher frequencies and so on. If I had a proper transducer, that's the next step actually, is another transducer similar to this, but quite a bit larger and designed as an actual transducer to, impart that high energy power. And there should actually be two of them on this flask, and this still stays as a pickup, and you use the other two to induce the actual ultrasonic signal inside. And as I've discussed before, the idea is to vibrate and form a standing wave inside that actually basically separates the water into a vapor bubble that then collapses and then re-expands, collapses and re-expands. And every time it collapses, the incoming water starts racing toward the center at an increasing velocity, such that it increases past the speed of sound into supersonic, and even faster. It actually, in theory, approaches infinity, the speed, but it won't actually. As it all comes to the center, it ends up imploding and giving off a high energy burst of up into the millions of degrees temperature at that atom, at that molecular level. Yeah, so anyways, that's the idea there. Sonoluminescence, getting a little closer, and it was fun sort of going through that.
I'm wondering if a sonar transmitter would have enough bandwidth to do what you need to do. Certainly have the power for it.
A sonar they call them transducers sometimes even. It depends on its frequency range.
A lot of the transducers you get for like fish finders and that sort of thing, they're a little bit on the low end, but they're very powerful and very sensitive.
Yeah, I wonder what frequency they run at. This is probably not a audio frequency. It's probably a higher ultrasonic, I think.
Yeah.
I wonder.
Well, third harmonic of what you're talking about is about 25,000. So you might be in a harmonic, but you'd be in the range.
Yeah, well, that might be what works too, is an actual harmonic, not the first harmonic, but second or third or whatever.
Hi, John.
Hello.
Hi, Mark.
Hi. Would that be like one of those hummingbirds that you like a depth finder for like fishing? Is that what you're talking about?
Yeah. Yeah, that would be on the low end of the scale. Something out of like say a 50-foot sailboat. You know, a real proper depth sounder, something like that. And I don't know, you might be able to find parts really cheap.
I see them.
Well,
I see them at the flea market and in the you know they give them away by the dime around here because we're around the water. You know the.
Yeah.
And
Yeah, it has to be the right frequency is the thing about it. I mean, you can buy transducers off of eBay. If you look at ultrasonic transducer, they have a number of different sizes and powers and so on. For somewhere around, in the 20 or 30 bucks up to $100 or so, you can get very suitable transducers. And then you have to have a circuit, of course, that's just a sine wave type circuit, or you could use a signal generator as well, which I just use an online signal generator for the signal that I was generating. And it has a sweep function where you can sweep from any frequency you preset it to any other frequency that you preset it to. And that way but the thing is, most transducers, ultrasonic transducers, are designed for a specific frequency. That usually 24,000 hertz is one of them, and 40,000 hertz is the other one. That's generally used, but you can get them up to a couple of 100,000 hertz as well. But generally, the ultrasonic people are using pretty much anywhere from 11 to 24,000 in that kind of range, depending on the size of the container. Is one experiment that was 100 milliliters, quite a bit smaller, so its resonating frequency is quite a bit higher. And there's another example of a 1 liter flask, which would be twice as big as this, and it had around 11,000 hertz resonating frequency.
May I ask you this question?
Yes.
Because last week I didn't get to make it in last week, but I got to watch everybody last week, and you were talking about these resonance and hertz and everything. And is this a way to measure the plasma? Is this what we're trying to? Is this our next step to try to figure out if it's pulsating the plasma? Is this the way to read the plasma? Or, like you were talking about because I'm ready to make some capacitors, and that one guy, that Tony, some guy made those chart of the capacitors, and you commented on but it was a very low resonance, like between 50 and 55 hertz, you said, for a small capacitor that he made. And you said that was an optimum range to be in.
Well, that was only because there's quite a range in the resonant frequencies, but one line had 55 hertz as the resonant frequency. And I thought, well, if you could narrow down, why not start your pulse at the resonant frequency that's normal for your country, for the power in your country, for the AC power. Perhaps that would be the correct pulse for your country. It would be 60 hertz in North America. It would be 50 hertz in Europe, and so on and so forth. And kind of makes sense that might be a normal pulse, but I don't know. There's different, like if you look up, I don't know, we could try looking up the two words plasma and pulse, or plasma and frequency, and try, I've done that before, and I've gone into different scientific papers and so on, and there is an actual pulse to plasma, and it's not really a frequency as such, because the frequency kind of gets messed up in plasma. You've got a lot of different fields going on, a lot of different frequencies being given off. if you listen to a plasma ball, for example, just a regular plasma ball, it'll give off all kinds of strange frequencies, some of them cascading and sort of like and this kind of thing, especially as you move a sensor, sort of like a crystal radio sensor or other kind of radio wave sensor, close to and far away from the globe, from a plasma ball. So in space, plasma, they keep telling us 99.98% of the universe is composed of plasma. And out in space, plasma is the modus operandi. That's the main method of operating in space. You won't find much in the way of hydrogen molecules floating around in space, but you might find lots of hydrogen ions, hydrogen, atoms, and so on. So, where was I going with that?
The measurement of the pulse of the.
Yeah. So, quite often, if you look into plasmas, like some of the traditional plasmas that scientists create or study and so on, and there is usually indicated a pulse, and it's usually in a low frequency range, like maybe somewhere between maybe 5 hertz and 50 hertz or something like that, in the low sort of audio range, which is kind of strange. But it turns out that the plasma or the flow or the way the energy flows in a plasma will be essentially at an audio frequency. It's an audio wave that can go through it, because the things are moving at the speed of sound, strangely enough, inside these plasmas, rather than the speed of light and so on. There's a lot going on with all that. So,
which is faster, the speed of sound or the speed of light?
Well, it depends, first of all, in what medium you're talking about. Because some mediums, the speed of light, for example, inside the sun, the speed of light is super slow. It can take years for a ray of light to leave the sun because the gravity is so intense. Think about that, eh?
And the sun is the sun basically made up of a magnetical substance, which would be like a CH3 matter?
I wouldn't go there. It's not. I don't think there's much in the way of matter, what we call matter, inside the sun. It's actually plasma. I mean, that's why they say 99.98 or whatever it is % of the universe is plasma. If you look at our own solar system, which is the weight of the solar system is mostly composed of sun. If you add up all the other stuff, it's just a tiny little bit compared to the sun. The sun is plasma, so therefore 99.98% of our solar system is plasma, which is a reflection of the galaxy, which is a reflection of the universe, and so on. It turns out that it's plasma wherever you go. I mean, we try to look at it as matter level, but the more you look at it, the more it's not matter in the way that we normally think of it as.
Well, maybe you could look at it more of as plasma fields, one field on top of another field on top of another field as it comes to us from the sun outward.
Sure.
That's how we perceive light, is a layering of the plasma. So
yeah, that's right.
So basically, what we're trying to because we resonate, like you said, we resonate at this level, at the human level. What is the human resonance of a human body? You know what I'm saying? In comparison to, like you said, like there's a 50 hertz here. There, can you take a measurement of yourself?
Well, there's definitely, which it becomes a matter of what do you want to measure when it comes to humans. Which level are you measuring? Are you measuring inside the cells, the actual, electromagnetic field from the voltages of the cell or of the field of the body and so on and so forth? And how do you measure? And our natural frequency, if you think about it, would be our heartbeat or pulse. We call it actually it's a pulse rather than the heartbeat. The heart beats, but the body pulses. So, and that's definitely produces fields. You can measure the heart field up to meters away from a human being. And that would be a pulsing, you can look at the heart rhythm graphs they have for electrical pulse of the heart and of the fields as well. It's a pulsing field.
I'm sure those...
If you look at it this way too, I just thought of this. I hadn't thought of it as a pulsing field before, but I think that would be the way to look at it. Very similar to my broken... Let me break out the other one here that I had saved for Guy. Sorry, Guy, you didn't show up today, so your toy gets confiscated, and we have to do something with it. Sure, it's for a good cause. Uh-oh, I might have just messed it up trying to get it out. No, I think it's okay. This one is kind of screwy, actually. They forgot to glue it or something.
Then it wasn't meant to be. Do not hurt yourself.
I don't even have my safety glasses on. I was trying to get it to do that double thing here, but this one's really messed up. I know what I can do is I've got some glue here, some super glue. I'll just glue it.
Yeah, Mark, talking about your resonance of the human body, if you look at the water that's in the body, the resonant frequency of a water molecule is 2.4 gigahertz. That's how microwaves work, which is extremely high. There's some talk that we are linked to the Schumann resonance, which I think is somewhere around 42 right now. It's even ridiculously high. But for years and years and years, it was around 7 cycles per second.
John, do you know how they measure that, John? Is that hard to measure, the Schumann resonance?
Yeah, it's very hard to measure, and that measurement of 42 is a little bit questionable too. Some people say it's still back at the same thing it was before, and so on. It's a bit of a controversy on that, but yeah, you have to have a long antenna, like several miles long, in order to measure it. And that can be in a coil. You can coil up a couple of miles of wire in a coil and do it that way, but it's not convenient. Let's put it that way.
Coil that we turn, or how many turns we turn, in just the mag revs alone. But I have a lot of turns in mine once it's done. I'm starting to put things together, and I keep hearing things like resonance and frequencies, and these are all going to start attracting things. And once I start moving.
Well, it's there's different things. Like if you were to think of what about your device, Mark? Your multi-purpose thing with things whirling around. You got this tripod and so on. Do you feel a frequency coming from it? Can you define it in terms of frequency, or is there a different way to measure that by like if you just see another machine that was whirling away, a different shape, a different size, different parts, but it's still doing some kind of similar whirling thing, I'll guarantee you that if it was a different inventor, it'll have a different flavor to it. It'll have a different feel to it. have a different vibe to it, right? It's like that vibe. What's the vibe? Vibe is vibration. That's resonant. That's frequency. But like you might say, oh, I got that guy, that person has bad vibes, man, or that person has good vibes, and vibrations. We pick up on vibrations all the time, but we don't define it as what was that person's frequency, or what was the resonant frequency of that interaction. We don't define things that way. We just take it naturally that, oh, I got bad vibes from that situation, or the
Yeah, but I believe that that's true, because I've been just recently learning about like you can take in other people's bad vibes because we're a receiver. So like say if for no other reason you're going to the shopping center, you're cashing out, the lady is thinking to herself, man, I hate my husband because he just cheated on me and I hate all men. Guess what? Now you're resonating with her frequency without you even knowing. Now you
Right.
go home to your wife or fiance, and that resonating frequency is still in your consciousness without you even
Right.
knowing.
Or
So
maybe
now
even in the food that was handled by that person as they did that transaction for you and filled the bag and so on. If they were feeling bad during that transaction, some of that energy could very easily be transferred into the food. We know that through the zinc and CO2 connection and so on, the amino acid connection with humans and emotion and food and all of that. Yeah.
So
So
if
go
we
ahead.
took our intelligence and we thought if that could actually happen, could you imagine having 7 billion people being upset with everything that's happening on the planet right now?
Well,
And having
that's been the
resident,
story of humans on Earth all the way along, though. All the way along, we're always upset about things. There's always issues, problems, all the upsets and secrets, and all of this stuff going on. Most of it, which is happening below the obvious physicality sort of levels. It's happening more on in emotional, feeling based levels that we hardly even acknowledge. We acknowledge when suddenly something is right in our face, and just before the bus hits us, oh geez, a bus is going to hit me. We didn't realize that we were walking out in the path of it by setting ourselves up for disaster, which happens all the time with humans. We self-sabotage, or we'll set ourselves up thinking that I can do this is fine, and all of a sudden somebody lets us know in a harsh way that it wasn't very fine, either the way they were treated or the way that the situation worked out, and so on and so forth. We see that in relationships all the time, and the extreme divorce rate that's happening, and multiple partners swapping and all that kind of stuff is indications of people not satisfied with what they have and whatnot. And yeah, it's the basic part of being human, but we can learn how to navigate in those realms. In other words, let's take the supermarket scenario. You walk up to the checkout and you notice this person's like just sort of not being up and friendly or whatever. Maybe there's something we can do. For example, I was at the cafe today for my daily coffee ritual, and the barista was a little bit sort of not down and out, but just wasn't quite there. And as I probed a little bit by just saying, talk about the weather a little bit and how weather affects people and so on, and that there's stuff you can do for that, and just sort of make a couple little suggestions. And she actually brightened up toward the end of our very quick interchange, and maybe it just helped get her over a little hump, and in her mood problem or something like that, or there's ways we can reach out rather than pushing back and just going, "Ooh, I'm not going to communicate with this person," or whatever, or "Geez, I'm feeling bad vibes from this person." Instead of our involuntary feeling of bad vibes, sometimes we can override that and deliberately cause good vibes in ourselves to override that and actually project that for others as well. And that means, control of emotion and deliberate creation of one's own positive emotion, which is kind of a strange concept for most people, or a lot of people, let's say, because generally as humans we're run by our emotion. We tend to go through our lives, and then if something hits us from left field and we go, "Whoa, that was a strange attitude, boy, that person's really messed up," and so on and so forth. But maybe we are messed up because we're not able to take in that other attitude, or accepted that someone could actually have that attitude, and so on and so forth. So anyway, there's I guess it's a realm that needs to be looked at. Go ahead.
There's definitely something to be said about that, and I'll tell you what. Just because I don't know why, but I'll just have to. I can only tell you my story about this and my reflections and my. But since working with Mr. Keshe's technology and all the stuff that we've been doing for a long time now, it's funny because I take this, I drink the CO2 water, and I treat myself when, like I said, with the shea and coke. I use the products that we work with. Okay.
Right.
Like you said, the situations sometimes arise where that were very annoying to me before, where I wanted to lash out and make myself over the situation. You know what I'm saying?
Right. Yeah.
But probably from the last 6 to 8 months, I don't do that anymore. I find empathy in so much now that it's almost bothering me, because I see the people that can't get rid of, it's an emotional thing. It's so emotional everywhere. And to me, I'm unemotional because I'm happier than I used to be. Because before, living where I'm at right now in Detroit, it's very, you can almost feel the taste of hatred is so great that it's almost palpable. You can almost taste it in the air. The people that drive around, the people you see in the grocery store, your neighbors won't smile at you anymore. But you know what? Since I've been doing this stuff and working with this, I don't know if I bother people, but I smile a lot more now. People look at me, I look right in their eyes and I'll smile at them, and they almost, it takes an effort on their part now to look at me. And I never used to look at people. I used to just go about my business and not bother with anybody. I knew what I had to do, and I just wanted to go home after that, because you just want to keep to yourself because you don't want to be bothered by people. Right. Now, I don't mind being bothered by people. I'm willing to share whatever needs to be shared, whatever. It just doesn't bother me to say hello, or just report. Could you get that from the top shelf? Or, I don't get, no problem. Here, I'll help. And to me, if I could make one more person feel a little bit more happier like that, this kind of stuff brings a little bit more easement to your soul. And you know what the funny thing is, I fought it because the last 3 sessions now, Mr. Keshe has been trying to teach us, you don't need all these things. Armin just told you don't need these things. And I kept on yelling, oh yes I do. I need to have these things around me. I need to have my hands on these things in order to make this correct. Well, it is mechanically, I'm a mechanical person and I do need that, but now I'm starting to allow my soul to relax a little bit. I'm actually feel a little bit more relaxed. I feel that there's hope on the horizon. Don't worry. Just the pressures, it feels like some of the pressure is off me. The next day will be a better day. Today was, every day seems like the same day as it was yesterday. You know what I'm saying? I still got to do the hard work. I still got to wake up and make my lunch. But I feel like tomorrow the breakthrough is going to happen, or the next few hours it's just going to be a grand. Something good is finally just around the corner. Whereas like 5 or 6 or 8 years ago, I would have never said that to you. I would have never even been on here. I would have never cared any less about anything. Mm-hmm. So as time goes on, progression has it that now he has taught us that open your soul and allow people to participate in the goodness that's coming upon all of us. These mechanisms we're right with them because they're an antenna that is allowing good energy to come to us. I think that's that's my guess. The Gans, the nano-coding, the wires, forget it. Enough of us to bring in these sort of vibes. We might not need these mechanisms. The vibes might be here. We might be able to overcome the CO2 if people get enough around it. We're as creators, as workers in our basements and our garages, we're creating these fields of goodness, and whether our neighbors know it or not, they're getting it too, because we're putting it out there. It's good. We're light. We're bringing in good light work. We're not harming people, and we're just kind of saying, hey, this is the way it was before, but if you want to try this, just take a sip of it, or just rub a little bit of it on you and make your hands feel a little better. And all around the world, people are going like, oh, wow, this is working. Like, I don't know why it is, but it is. And I didn't mean to go off on all this stuff. Sorry, buddy.
No, thank you for that testimonial. That's what it's all about here. So it's perfect, Mark. Thank you. It's good to hear. Good to hear.
So one of the things, got some really great stuff looking there too. Hi, John.
Hi, how are you?
Good. How are you?
Oh, fine, thanks. Yeah, what I was going to say in the conversation is both of you guys are absolutely right. We have to remember that we are energy beings, and that everywhere we go, and every thought that we have goes out into the universe. So in Rick's case, his kind words and pleasant personality to the other person was like a light bulb that radiated out, and that radiating out of his energies helped balance the energies within another. So if you go through your day on a constant basis of just remembering that everywhere you go, that you have an impact on people, the thoughts that you carry, the emotions that you bring forth are important. And what we have to do is realize that with this new technology and where we're going, the responsibility to keep our thoughts and ideas pure is going to be important for us. Now, one of the things that in our Arizona facility, right now we are, I'll say, broadcasting out energy fields that go out over 200 feet out in all directions with our spaceship. And the people that come into our environment, they almost to the letter, they say, something's different in this environment. It feels good in here. I don't know what it is, but something's different. I feel good. And it's like that with the energy fields. They're going to take our emotions and balance them. I was explaining to somebody with the MagRav units how certain MagRav units have been reported where they didn't perform as well as they did in other people's household. And I told them that one of the reasons is because there's a consciousness associated with the magravs. They put out these plasma fields. It has a consciousness, and if we can interact with that consciousness, we can have better success. If we're constantly taking from it to balance out our energies rather than giving to it with our positive emotions, it doesn't. It can perform either good or bad depending on which way we go. So yeah, what you're saying is absolutely right, and where we're going with all of this is to realize that there is this connection between the science and the spirituality that is vitally important.
Yes, thank you, John. That's a good point. Very good.
Yes, thank you, John. And Mr. Keshe really drove home the point for the last couple of 3 sessions. And I think you can agree that the soul means the whole thing is the connection to these devices, in which the more connection that you can have to your device, it's more manifesting your particular needs and your field. So I would just like to ask you guys out in Arizona, the measurement of the fields, or is it just your personal feelings? Because I'm starting to put some things together, and the fields are getting, I have more things here now by myself, and it's getting to a pulse point where, you know what I'm saying, it almost feels like when I go to work now, I can't, that my stuff, I feel like, well, I got to get home because I got a couple more things I want to do. And, you know, once I get this done, I'm ready for this next step. And does it feel like that for you in Arizona?
One of the things that is important in all of our construction and our activities is our intention for what it is that we're doing. I was mentioning the other day how, you know, we're trying very hard to produce the Gans of hydrogen. And let me say it this way, that it will come to the person, how do I want to say this? If your intention is correct, then you'll be able to create what it is that you desire to create. So as we go through these experiments, you're going to find that certain people are doing the exact same things, but one person is going to be successful and the other isn't. Because as we're moving into some of this new technology, it's of a higher vibration. And if you don't operate on the higher vibration, then you're going to have trouble finding the key to the ignition. Let's just say we're tinkering on the edges right now.
Tinkering on the edges? Is that what you said?
You know, I was watching what you were showing last week, Rick, with your vibration and finding the frequency of the hydrogen atom, and I think you're on the right path there with the combination. Because one of the things we're trying to do with spinning of reactors, and I think you can do it with spinning of reactors. But also, Mr. Keshe has said on a number of times that you don't need to spin them. And I think what you're doing there with the frequency is the right answer. Putting the frequency into the water, or these hydrogen atoms to change them.
Yeah, well, when you think about it, water is pretty special stuff, as we know. But it's interesting if you think of water like you talk about the Gans of hydrogen, for example. Like normally when we make Gans or create, then we usually there's water involved, and we create oxides, and from the oxides we end up creating the Gans and so on and so forth. Well, this is actually already an oxide. It's hydrogen dioxide. Dihydrogen monoxide, I should say. It's not a dioxide. It's a dihydrogen monoxide. That is actually the name for water, H2O. So it is an oxide. It is already in the nano, in effect, and so we should be able to quite easily convert it into Gans. Perhaps it already is in a certain way. But the way I look at it is that if you look at water like a plasma, then there's actually a unique thing that happens with water is its self-ionization. That water will actually self-ionize. That means it turns into its plasma state naturally. Each water molecule does that roughly every between 10 and 20 hours. It will spontaneously, out of the blue, separate into its hydrogen and oxygen components. It's a bit more of a complex reaction that takes place. There's several H3 type structures that are involved in other, not just straight oxygen. It can be in other forms and so on. But that reaction of turning into essentially hydrogen and oxygen, separating the molecule, not in its vapor form, but in its actual separation of the atoms, which takes a high amount of energy to do. But it spontaneously happens about once a day, let's say, to every atom, to every molecule, water molecule. So this flask actually has millions of molecules that are doing this all the time, breaking up. But the problem is, as soon as they break up into that hydrogen and oxygen, they immediately recombine into water again. This is what's known now as the fastest reaction they've ever seen or measured in chemistry. This recombination of that spontaneous splitting and recombination of the water molecule. So I think it's fascinating that this water sitting here, this half liter of water, not only has spontaneous liberation going on, spontaneously causing plasma inside of this. I mean, we call it plasma water and so on, but it actually is, in the scientific sense, creating a plasma while it separates into the ionic forms and so on. And that takes a lot of energy, and it turns out there's a lot of energy going on inside of water all the time. And the waves in there, the cosmic rays that are coming in, and other interplanetary rays, as well as the local energy systems and radio waves and other things, are all combining. Once in a while, the fields will combine together to provide a big peak of energy. And wherever that peak happens, whatever molecule of water is right beside that peak when it happens gets split in half and then instantly comes back together again. So I think this is a fascinating, wonderful discovery about water. It's only been discovered in the last few years, that this self-ionization concept. And they've only been able to measure it because it's in picoseconds how quickly it separates and comes back together. And they still haven't figured out all the ins and outs about it, but they know that much about it, basically, and some other little factoids. But it's a wonderful substance to look at as, the way the universe works, essentially.
So what if we took something like um, a plasma C3 and tried to pull apart the carbon and the hydrogen atoms using the frequency?
You mean the hydrogen and oxygen? You said carbon and...
CH3.
Oh, the CH3, I got you. Okay.
Because I think
Using frequency, right.
I think that's what you're doing with the frequency. So what we're getting close is I actually think I might have some of the hydrogen Gans, but we haven't figured out how to test it properly, other than spinning it. And I think you can also do it with frequency.
Right. Well, entirely possible.
You're always going to come back to that matter state.
Well, the thing that I would like to experiment with this particular deal is, what if, for example, we had CH3 plasma water inside here and create a sonoluminescent bubble. So now that little bubble, instead of being water vapor, a combination of water vapor and air, it'll be a combination of CH3 vapor, water vapor, or CH3 plasma vapor basically, plasma gas, and it would be pulsating instead of the regular water.
I think that'd be a very interesting experiment.
Yeah, and we could try that with others, such as the copper oxide or...
No. Say with the hydrogen atom.
Well, the other thing about it is, it's possible also to spin this, or even without spinning, and actually insert a hydrogen bubble inside. And that would be interesting too. It could be through, maybe a syringe sort of situation where it's easy to fill the syringe up with hydrogen, or not even fill it up, would just mean a tiny, tiny wee bubble, all that you would need. I mean, the bubbles that they work with in sonoluminescence are, well under a millimeter. They're in I think up to like 50 microns or something like that. It's very, very tiny bubbles.
I don't think you want the hydrogen gas.
Well, the thing is, though, if you were to use, there's another option. Say this was spinning, or some other orb similar to this class one, and it's straight liquid inside. It's already degassed. You could still have a means of generating hydrogen inside. For example, if this was a weak caustic and you put a piece of tinfoil in, it would generate actually atomic hydrogen until it combines into a molecular hydrogen. But initially,
you don't want the gas, though. You don't want just the gas.
You would have at least then the atomic gas, and it's created, in a rotating structure. It might have special properties where the molecular weights get separated of the hydrogen and so on. But so I'll go with what you say, though. You don't want the gas.
I think what you want to get to is separating the hydrogen atom away from, like what you're doing with the water, but you have to put it in that plasmatic state. So CH3 is good. The Gans of hydrogen is good. Other.
John, can I ask you why you just used suggested CH3?
Because it's got the hydrogen atom in there.
And that's the heaviest part, which is the magnetical part? Or is that the gravitational part, which you want on the inside of, would you use, what I'm trying to wrap my head around is CH3 the only thing, or is one of the things that we have to work with as a pull point?
A pull point? Is that what you said?
Pull, P-U-L-L.
Pull
point.
Yeah, Mr. Keshe has referred to the CH3 as tritium Gans, which is the 3 hydrogen atoms. So what Rick's doing there with his frequency is he's pulling the molecules away from each other, its original structure, with the frequency. And I think if he did it and he found the right frequency with the CH3, he would, in essence, have a truer either hydrogen Gans or deuterium or tritium that would be in a Gans state, which then, if you spun it, would open up this bubble of energy field. That's my thinking.
Yeah, but it would already be created once you wouldn't have to spin it because it would already be created in that tritium field.
That's the beauty of it. And that's where, we get away from the spinning, like Armin was saying, that you don't need to spin. I think that's where Rick is walking down this path of unlocking the door of how you do it without spinning. Lock into the frequency.
So that's what I'm hoping to do with my some of my things that I'm working with, and that's why I'm asking you if you used in a CH3 as a center position, if you had that as a center point and use CH3 or CuO or CO2 as an external, which would mean the outside of the CH3, which would bring that into the CH3, meaning that would be CH3 would be a pull point, and if we had a nano coated wire through the pull point, which would pulsate through what the Gans, the CH3 Gans produces. It produces something that's pulling, and then we have to move through that CH3 and then outward again to those external without mixing the two. Does that make sense to you?
Okay, have you heard the conversations about the mass, where we talk about the mass ratio between the inside and the outside?
Yes.
So if you let's say you put CH3 in both the inner and the outer, if you put a small amount in the inner and a larger amount in the outer, what happens? Because the larger amount is stronger, it has maybe 10 times as much as the inner.
Right, exactly.
Material.
Right.
So it pulls it out, and it's both of them are CH3, for example. So the mass ratio is one of the key components in how you figure out what you want to do, whether you want to pull the energies inward or push them outward.
Which would create a pulse. Do you think?
Okay, so you're saying pulse. Why do you need a pulse?
Well, isn't that where we're going right now?
No, what you're trying to do is you're trying to open up the fields. Like it's going to, like Rick was talking about in some of his earlier conversation. It's like a light that will open up and brightly shine 10 times brighter than start like a little bubble, and it'll be a bright light, and then it'll be a bubble of energy. It'll be a field. This bubble of energy will be a field of energy that will consume your space.
I understand that part, John, but the part that I'm trying to understand is how do we keep that perpetual motion going? Isn't that where that's the whole thing, without having any electricity or any kind of zapper going or anything like that? In order to have a constant pulse in our Gans and in our nano-coated wires, it has to have a giving and it has to have a giving and a receiving within the whole unit. This is my whole concept, is that these units have to be able to give and receive on their own. We should not have to assist it. And that's why I'm trying to, like when you're talking about hydrogen, well, I better not go off into a tangent.
Well, it's not a tangent. I think you're on track here. So if you want
Well,
to,
I think you're really on the right track, I think, Rick, with this whole concept of the frequency. That's how we get away from spinning. And that's how it has that pulse where it operates in this environment. And now, okay, so where we're really all going is all of these are like but bridges to the next level. What we'll find is that when we figure out the frequency and we give it that frequency from ourselves, we're able to truly not need any assistance. So that's where our soul and emotions come into the equation.
Well, John and Rick and everybody, you have to forgive me, but I missed 2 sessions, and you know how that goes, that I've got 2 weeks worth of all my stuff that we talk about each week, because this is a way to get our emotions out, to talk to each other. You can't talk to family and friends because sometimes you're a weirdo, you know what I'm saying? But as you get more and more, but I'm sorry that I took up and I have all these pent up things, and you know how after 2 weeks of not saying a word to anybody. So please, let's go to Lee. Look at that amazing thing that Lee has for us in front of us. And I'm sorry.
we better have a look at that here. Let's have a look at that contraption, Lee. What do you got wired up here? It looks like a hospital lab.
This is MOSFET Rashid. I have a little bit of things about what John talked about and also what Rick is talking about, capacitor, pulsing or frequency generation. So if you look at our capacitor, it's, as Tony Sayato has some experiment done, so it can create frequencies. So if you look at a capacitor that we have, which is a complete inductance, capacitance, LC circuit. So you have an LC circuit. So if you have an LC circuit, you can generate pulse. So if we have a better characterization of the capacitor, we can generate pulse. And this is one of the things I'm looking into right now. And it also has a diode.
Hello, could you slow down? Because you're talking really fast. And
okay, I'll slow down then. All right.
Good. Yeah, be good if you say that again and clearly, a little more slowly. I caught it, but Mark can catch up, and other people.
I'm just working on a capacitor that I just realized that we need a resonant, and I'm just, I looked at the last couple of workshops, and so now you're going to explain what a resonance is in a capacitor, and I'm trying to understand what we need in a capacitor right now. Thank you. Sorry.
Okay, go ahead.
Our capacitors is not really a capacitor. So the interesting property of the capacitor is that we have a winding, which is, in electrical terms, it's called inductance. So the inductance is the opposite of a capacitance. Capacitance, you store charge, whereas the inductance does the current part. So it's the opposite. Yes, I'm trying to simplify a little bit for those who are not familiar with the electrical side of things.
I see.
including
Sorry the
diode
live
properties.
stream wasn't on there. I didn't get that little blip on live stream. Basically, let me just say quickly again for the people at live stream about the LC circuit I was talking about, which is called a tank circuit. The L is for inductors, C is for capacitor. The inductor stores the magnetic current, the capacitor stores the electric current, and it's a different way of storage back and forth, and they bounce back with each other and create a resonant surging from one to the other, basically, and that's the tank circuit that will resonate at a particular frequency or frequencies. All right, go ahead there. Sorry to go backwards again, but go ahead, MOSFET.
So if we can characterize how this inductance part and the capacitance part can be changed through Gans and through materials and also dimensions, and this will require a little bit of work. And Tony from Japan, I saw the Facebook, and it was in the last Cosmic Reactor groups. I mean, there was a, I think Sander talked about it. Remember this Japanese guy? His name is Tony. He characterized capacitance using different ends and some material, different material, right?
Right. Yeah.
So that's one aspect of this characterization of capacitance. There are some electrical engineers involved with me as well. I myself is one. And we are looking into doing some characterization along some other dimensions of capacitance, like if you put feedback, which is one of the types that was introduced, split capacitor, early on by Mr. Keshe, which wasn't investigated a whole lot. I did a little bit of some of these things, and it was it definitely, the power, I mean, with the hand you can feel that there is a difference in power if you do the feedback. But beyond that, we didn't have any measurement. But now with Tony's approach of adding known capacitor value so that you can better characterize the unknown part. So this is something it will require a bit of work, but it's worth investigating, and it may also lead to figuring out what are the different frequencies or pulsing that we can generate from changing various properties of these capacitors.
Mm-hmm. Yes.
Does it make sense, or am I too fast?
No, made sense to me. What about you, Mark? Does that ring a bell?
Left field for me. It rings no bell for me. I'm sorry. You know.
Do you have any question?
I have a ton of questions, because in a capacitor, when, I don't know anything about a capacitor, but in a capacitor that I've just learned about, the acid that's in the capacitor, like Rick said, one is one is a magnetical, one is a gravitational. But what separates that field? I mean, what keeps those, or are we just having those two elements together so that they are atomically moving in one container? You know what I'm saying? So you put the zinc in the like the Baghdad battery, they just have a zinc, copper, and salt in a vase, in a vase, and it gives you a battery. So, I mean, is that a capacitor? Because it's allowing the ions in that space to hold or create motion between the copper and the zinc in that container.
Generally, in a battery condition, it's more of a chemical process. In terms of ordinary science, at least, it would be considered a chemical process, not like an inductor or a capacitor, which is basically the storage of charge on a surface or in a magnetic field.
Where does this separation come from?
The separation in the battery, you mean?
Or what you're just explaining. Where does that, in the capacitor, where is that?
Okay, well, let's look at it. Let's do maybe a whiteboard on it and see if we can draw it a little bit. Okay, let me just get this set up here.
I'm sorry. Because I've
No,
never,
this is a good question that lots of people do have. So maybe we can explain it out a little bit.
because in the
Okay.
capacitor, in Mr. Keshe's capacitor, you have from inner to outer, you have a copper wire with the insulation of the wire, and then you put the Gans on the outside of that wire. Then you wrap it with a non-flammable tissue, like parchment paper or whatever, and then you have another zinc or foil. Some people were putting zinc in foil, and then they were wrapping it with two coils, one feeding back, or the five,
Yeah, it's starting to get really complicated there without looking at an actual drawing. But let's start out with something very simple, like if we look at just a regular coil that we are used to dealing with. Then if we were to have if we were to have, say, a plus and minus or a potential on either end of that coil, then it'll create a magnetic field, and that magnetic field contains the current in a in a field. It'll store that current essentially. Now, if you have a capacitor, a basic capacitor is composed of two plates, let's say, and you could even look at it more three-dimensionally if you look at it like two plates that are close to each other. And so you have a wire attached to this plate, and you have a wire attached to this plate, and again you have a plus and minus condition, or a gradient basically between these two plates. So what happens is, if you were to hook up a battery to this circuit, you end up with, it charges the plates. So you get a bunch of plus charges on one plate, for example, and
Are those two plates laying on top of each other with nothing in
well,
between?
here's the deal. In a capacitor, the plates have to be separated and not touching each other, because that would allow the charge to equalize. And the whole idea with a capacitor or other circuits like that is to separate the charge, and that's what gives you the potential, right? So if one plate receives a positive and one receives negative, or becomes positive and becomes negative, then it builds up the charge, and the charge will be continued to build up according to how far the plates are from each other for one specific kind of one variable is the distance there between the plates. The other variable is the size of the plates. So two bigger plates close to each other will have more of a charge, or can have more of a charge, can be charged up more than smaller plates that are the same distance from each other. In a similar way, the closer the plates are to each other, the more the charge, the more intensity of charge that can be built up. So you want them really close together and really large plates. So what they do normally is you take a foil and you wrap it up in a spiral, and you put it inside of a tube, and you hook up your wires to it and so on, and you can actually have make a capacitor as long as it doesn't all touch inside. So you need to have an electrolyte or a spacer in between these plates. And they might use plastic film, could work as a spacer, or you might have oil in between. For someone like Tesla, he had huge vats, big vats of oil,
What about that?
and
Like,
had plates inside that were separated by the oil and so on. And he would have a huge charge built up in these capacitors that he built that were running his Tesla coils and so on. Sorry, what was the question there, Mark?
if he had something like that, could you get electrocuted from something like that?
Absolutely, yes. You can get electrocuted from you. You have like capacitors that look kind of like this, and they're kind of like hand-sized or whatever in a microwave oven even. And they could even be just 250 volt or something like that. But you charge that up on its two terminals, and if you were to accidentally put your hand across it, it could kill you because you have 250 volt at quite a few amps or milliamps depending, and enough to kill someone. So yes, capacitors can be very dangerous that way. That's why they often have a little resistor that's attached to the terminals. It's called a bleed resistor, and that bleed resistor will gradually, maybe over seconds or whatever, bleed down the voltage in a capacitor if it's in a certain circumstance where it is not supposed to remain charged up, because it could be a safety item and that kind of thing. A lot of motors will use a capacitor like this, a starting capacitor it's called. A big thing that looks like a huge battery, almost a metal canister like. And so there's all these different types of capacitors. They use capacitors in sound systems, and these fancy sound systems in cars that have big bass woofers, that take
Right.
a couple thousand watts and so on. You run a capacitor, and the capacitor acts like a battery. It stores up the energy, but it can deliver it close to your system, to your amplifier that needs all that power. Instead of running huge big cables to the battery, you can run smaller cables and a large capacitor close to the amplifier, and whenever the amplifier needs a little bit of extra oomph, it draws from this capacitor, because it's more or less instant energy that can be delivered through a capacitor compared to a battery. Because the capacitor has the charge stored on plates, or in a similar manner, it can be more or less instantly discharged within a second or two or three, compared to a battery, which would maybe take an hour to have an orderly discharge, or half hour or something like that, say, without overheating and frying itself.
Would you have it discharge from a nano-coated plate to a non-nano-coated plate?
Well, that's a good question, and there's still a lot of work that needs to be done with nano-coated plates to see, say if this was nano and the one underneath was non-nano, would that make a difference? I don't really know. I think it would. I know that the nano-coated plate, it has that surface resistance. So in effect, I think that it would be possible to take for example, two nano-coated plates, or a nano and non-nano-coated, and put them right together, and technically there shouldn't be any interchange of they shouldn't short out, because of the nano layers are very, very high resistance, and there shouldn't be any interchange between the non-nano-coated and the nano-coated plate, even if they're put directly together, unless the nano-coating wasn't quite correct. But that still needs to be tested and see. Say again?
You know what I'm saying? So now that you know what you're saying, exactly what you're saying there, in the same idea as a capacitor, if they were together like that, non-nano-coated and nano-coated, where would the action be, or would there be action? You know what I'm saying?
See, the thing with the capacitor is you still have the fields in between. There's always there's this tension or gradient between this plate with all of its charge, and the other plate with this charge. And so it's a sort of like two magnets, a positive pole and negative pole.
The nano-coated plate would be the positive charge. It would accept a positive charge.
I'm not clear on that. I thought that the nano, well, maybe it will accept positive, but I thought the nano is usually attached at least to the negative side of the battery.
Okay, so it should be flipped around.
If that would be the other way around to look at it that way, I suppose.
Yep.
But I'm not sure. It may end up
Now,
just because it's attached to the negative side.
A raw copper wire would accept a positive charge. They do it all the time, right?
A raw copper wire.
Right.
Well, it in a different way. Like this, say this coil at the top here. Say that was a copper wire. It accepts a charge even if it's a straight wire. Let's say it's just a straight wire. You have there's electrons and there's charge that moves through the wires. Electrons actually move, say, one way, and the charge moves the other way. The actual the field or the charge moves one way, and the electrons move the other way in the wire. Now the charge in the wire moves at basically the speed of light, but the electrons actually move very slowly. It could take an hour for the electrons to move along this length of wire, for example.
Well, don't they say that it stays on the outside of the wire, not the inside of the wire?
What stays?
Well, like the positive part of the wire is the external part, and the internal part of the wire is the E, which is the go in the opposite direction, would be the tubular effect of a copper wire.
That only applies in AC circuits, and it depended on the frequency. The higher the frequency, the closer to the surface the charge sits.
Yeah, I think it's on DC as well, though. For if it's a flow of DC current will still be on the outside of the wire, on the outer electrons, basically, of the wire, is the way I understand it.
On the outside.
We're talking about the charge or the field effect, but the actual movement of particles will be the electrons, which will move in the opposite direction.
Which would be away from the higher, well, it's getting away from the magnetical, which is, like it's a separation. So the heavier parts move away from the lighter parts, which move energy in towards the field, which would be your cores or your magravs or your everything that is internal. That's the whole thing I'm trying to think about right now is what comes from the outside to the inside. What's bothered my thinking right now. It's from out, because I have a copper nano-coated wire on an inside hollow tube, and now what do I fill that hollow tube? Because I'm going to bring external elements from with the nano-coated wire into I want to pull something into that tube, and that's why I keep thinking that CH3 pulls into the tube. Once that gets inside the tube, it's a live wire with CH3, and as it goes through the tube with the nano wire and the CH3, if there was something on the outside of that, which is my copper wire, if I put a CO2 or even all these other exotic Ganses that people are starting to make now, if that was on the outside of the rings, the copper nano-coated rings, as the energy goes through the inside, it's pulling all that to the inside and moving it to the outside. You know what I'm saying? It now creates that flow. That's my intention with the hollow tube, and my hope is that the CH3 is the heaviest part. I never wanted to use lead on the inside of any of these tubes because it's harmful. But now I'm learning that all these everything else that we've made is an oxide, which is outside. Oxide outside, CO2 outside, CuO outside, CH3 inside as a not an oxide, but it's the only thing we make that is not an am I saying that right? An oxide?
Well, it's a good point. Yeah, I guess so. So I've heard you keep saying that as a receiver, but I think of the CH3 as a giver more than a receiver. It's giving the hydrogens is the way I look at it. But any input on that?
Make hydrogen?
You're correct, Rick.
So it's like, but I mean, you can still use it. The way I understand it's used in the outer, like in the example of a tube and a wire inside. Maybe could be used on the tube. You put the CH3 on the outer, and it essentially feeds the inner. I'm not clear on that actual process, whether the hydrogens actually separate and end up interacting somehow in this, or if it's just the fields are enough to have the CH3 fields and have those, the three hydrogens. They're like little tails, basically, attached to the carbon, and they end up connecting with things and being useful. You could break one off or break two or three off and use them. All of a sudden you have a hydrogen ion ready to be used, and so on. So but what's in between here, between the wire and the tube? That's a good question as well. Now we know we're getting some traffic going on or something there in the background. We know that a wire, for example, will have a field around it. So the wire will have a particular field all around it, and same with the tube. The tube will have a field, and it'll have a different inner field than an outer field, and so on. And so what might be happening between the wire in the center and the tube? Is it like an air atmosphere environment inside, or maybe there's some sort of goo that we put in that's a Gans goo or some other substance, metallic substances and so on, as a dielectric or as a conductor that might influence that environment. There's different ways of looking at that, and lots of different combinations that people have used in that environment as well. And also another way to look at it is, what if we created a vacuum inside here and didn't put anything inside? Perhaps that would be a way to go, because maybe that would be much more close to the way nature, the way the universe works. I mean, you go outside of our atmosphere, it's nearly a perfect vacuum in the rest of space, and that's where all the action is, really, in that environment. Maybe that's what the environment we should be creating. We haven't really experimented much with a simple vacuum environment with these structures.
Can I share a quick picture, Rick?
Pardon me?
Can I share a quick picture?
Sure, yes, please.
You have to stop, okay. You see that?
Yes.
Okay, so what we did in this particular case was we put, this is nano-coated on the inside, and we put I think we put the oxides on the inside. Or no, excuse me, we put the CH3 on the inside. We put the oxides on the outside. So we have nano-coated inside and this nano-coated outside. And we tried to put them in this delta configuration to try to amplify some of the power. But this is kind of what you were talking about a little.
Mm-hmm. Yeah, very much.
So when you nano-coat the inside with the Gans material, you're taking those fields, radiating those outward, and you're radiating them out even more when you have these nano-coated wires and put Gans material on those. So it's like you're amplifying out and then you're amplifying out again.
Mm-hmm. Interesting. So, but it's
we use these things as power boosters, is what I call them.
Are they sealed tubes? They have a cap on each end?
A cap on each end.
Okay.
These half-inch copper pipe.
And
Cap on each end.
Soldered on. They look like they're soldered on or whatever. I think yeah.
Yeah.
But they've been nano-coated on the inside of the tube.
On the inside.
Okay.
Only, and so the outside is not nano-coated.
Yeah, it'd be interesting to have a wire in the middle of it to sort of pick up on the energy in there or whatever.
I think we're actually picking up on the energy in this. It's like fields of energy.
Yeah, definitely. So did you get any results from that? Like anything you could measure or not?
So it is helping the spaceship. We put 4 of these around the spaceship, and we feel that it's amplifying those fields.
Mm-hmm.
This particular delta configuration, we hooked up with the mini high voltage transformers to try to see if we could generate some larger fields that we could measure,
mm-hmm.
and didn't get the results that we wanted.
Mm-hmm.
But I'm not going to say that it doesn't work. I'm just going to say that we didn't get the results that we were looking for.
Okay, and just to, I noticed you use what's called the Armin connection there, I guess, with the coil around the wire. And John and I were discussing that earlier on which way do you think the flow is, the plasmatic flow is going in this combination? Which would it be going like clockwise or counterclockwise in this configuration?
So we usually wind our wires clockwise. I'm a little upside down. Yeah, it's clockwise. We probably should have, this is not a good situation here. We should have coated the end there, and we should have bent these back around. Because anytime you have open wires like this, the plasma flow just escapes.
Right, yeah.
So you really want to be bending these back around. I think this was an early picture before we actually did the test.
Right. But aside from the coil direction and so on, which way would the flow be going through the whole structure, I guess? Like, does it go through the little coil wrap and then into the straight wire, or from the straight wire into the coil wrapped one?
So
you know what I mean?
This was supposed to flow in a circle or a diamond shape.
Yeah.
I'm not really sure I understand your question.
Well, would the flow go around this way? You can see my arrow like going around counterclockwise, or would it tend to go clockwise through the whole configuration?
So over here, this would be my arrow. Can you see my arrow?
Yep.
See where we would put our power over this way.
So that'd be the input.
Power would be coming in here, be coming through this one, going around. This connection just ties these two together, coming around. And then because it's plasma fields, we can tie it back into itself. That's the beauty of the delta configuration.
So does the plasma continue through that coily thing then, where your arrow is, and then back through again, right?
Thing, like amplifying each time you go through. That's my thinking.
Right. Right. Okay.
Once you're in the plasma state, you can go back in on itself.
Well, yeah, that's the part that gets a little confusing, does it? Well, like, for example, would not the plasma try to go back to the source of the electricity coming into it, of the power coming into it? Because we know
so
that the plasma tends to go back toward the generator, the source of the energy, in order to nanocode everything, for example.
You're right. For example, in our case, we're putting the energy goes back into the grid.
The plasma.
Plasma energy goes back into the grid.
Plasma energy, I guess, yeah. And possibly electrical energy, but...
Oh, yep. I would say it probably does go backwards into the
So this gets back into our discussion earlier with John about maybe the plasma goes in both directions at once, or can we actually guide it to go one way? I mean, that's sort of the idea with those connections in a way. It should be sort of a, it guides and it's able to, like go through, but yet...
It continues the path, if you will.
Yeah, yeah.
I think the plasma does in fact have a direction. So in other words, as it's winding through each one of these coils, it's continuing the path. Although it does radiate outward, it will radiate out fields, and it will also send fields back through the electrical system.
Hmm. Again, it's since we don't have a definitive way to measure those plasma fields in a way, it gets a little bit nebulous that way. But if I was to think about, for example, if we took this whole configuration that we see in front of us here, the 3 tubes and all the coils and the whole works, if we were to put that inside of a bell jar vacuum chamber, a regular vacuum setup, and vacuum it out, and then put a little bit of high voltage, or not that high voltage would be required, and then these configurations would start to glow in that familiar blue sort of purple plasma glow. But it wouldn't necessarily, the whole configuration would tend to light up, rather than, it would be obvious that the plasma isn't really flowing through each wire necessarily. It just flows over the whole structure. This is something I noticed some time ago working with vacuum chambers, and when I first put a plasma ball inside of a vacuum chamber and watched the electrical circuitry, and was in amazement that the circuitry wouldn't work properly because it was basically shorting out internally, because in a vacuum all the electrical parts start arcing over in field conditions, and things that were separated in air are no longer separated electrically in a vacuum. They create these fields that end up causing ionization of the gases and strange shimmering, light given off from the plasma structures and so on. So plasma, in that sense, the ionized gases, at least the visual that we see when circuits are activated in a vacuum, it behaves a lot differently than I expected. When I first saw it, I thought it would be, just certain places that would show this plasma field over it, but it seemed to just grow over the entire circuit, basically. It didn't really discern between copper tube or copper wire or other things, just sort of crawls over the whole field, you might say, the whole assembly. depending on the exact vacuum condition and
Yeah, I
how
think
much air.
that's an interesting point. I think you're probably more right than maybe my thinking of the traveling, because you're right. It does spark across or jump across. It's like a field of energy versus uh, our thinking a flow of energy.
Mm-hmm. Like it likes to flow, but not in the way that stuff flows in a wire in a very defined sort of place inside the wire. At least we thought it's inside. It seems to be inside the wire. Whereas we see visually, this plasma thing seems to flow all over the wire and into other parts and so on that aren't necessarily even wire, because you can start to see the fields that are outside the wire when you deal with high voltage plasma.
Breaker, this is Denny.
Hi, Denny. Thanks for breaking in. What's on your mind?
Just for a moment, when you look at those coils around the pipe, you can imagine each coil as a reactor. And so each reactor or each coil has a different strength. Some of them would be very close together to the same strength. Now you've got them in a triangular shape. So the coil that is weaker in one of the triangular shapes, the strength of the one that's larger will tend to go to the weaker. And so you look at those coils plasmatically as reactors. That's one concept that you can think about. And when you're constructing some of these things, if you look at the coil, not only directionally, that you want it to go and give your plasma to go a certain direction, you also have to realize that it can go to a weaker coil in another direction. Because I've been trying to get my my plasmas to head to a center point, so that I can increase the strength of the gravitational, and then have the gravitational turn into magnetical and head back out from a center point. So and when you're doing it with the coils, you also have to look at them as individual reactors. I think that particular topic came when they were making those spaceship egg-shaped coils, and Mr. Keshe mentioned that the loop coil around the axis, all the turns act as reactors as well. That's when the Philippine Innovation Group was making that type of hardwired spaceship reactor.
Yeah, good point. Someone mentioned, I think, even using different kinds of Gans on each individual coil of the coil. So you could have, one coil with Gans and different kinds of Gans in different sections of your coil, and actually have different effects that could come out of that.
Different types of wire, different thicknesses of wire, different different diameter of the coil, how tight you make the coil, how loose you make the coil, the type of Gans you put on the coil, how many different coats of the Gan. When you get back to the CH3 that Mark was talking about, Mark is right in a sense that you can have the CH3 as a receiver, because if it's sitting in a weaker strength, then the stronger plasma will go toward it. In other words, it'll feed it. And so you can sense magnetical and gravitational are pretty much one of the same things. You look at the differential. That's one of the concepts a person might want to consider when he's doing these things. I'm not saying that I'm totally right. I'm just saying that I need to make my experiments to find out how it happens and see what kind of results I get. Thanks for allowing me to intrude.
Thank you, Denny. Always like to hear your
Breaker.
input. Hello, Mark. Come in, Mark. Over.
I just wanted to say hi to Denny.
Likewise. Hello, Mark.
I gotta, if I get time tonight, if we have a little extra time, I did something just on your behalf tonight, and if I get a chance to show it, I want to show it to you.
Well,
Alrighty,
with
thanks.
a lead in like that, then it seems like it might be a good opportunity to do so.
Oh no, let's look at Lee's stuff. Lee's been waiting.
Okay.
I mean, come on. Yeah. Let's go.
All right. Well, if there's no other questions immediately for what we just talked about, let's move along. See, there's a couple things in the chat here. I just haven't read them all. All this, there's a bunch of things from Jay and so on.
Rick, this is Mosvik again. I have something to show, actually, along the line of Spaceship.
Okay.
Should I go ahead?
We can go ahead before we dive into Lee's stuff. Sure. He's being a little quiet there, so we'll have to prod him a bit later, maybe. Go ahead. I'd like to get your input. Did you want, do you need to share the video or the share screen? Are you still there, Mosfet? Oops. I think he went bye-bye. Maybe he'll come back in.
It looked like he was having trouble with his audio, and
Right.
probably not only it, but others.
Maybe he had some bandwidth issues or something there. Well, we can come back to him when he comes back in, I guess. Don't see him back yet. Might have to restart or something.
I got another quick one I can share.
All right, go for it, John.
This was one of our mag graphs that we put together. You were talking about using different kinds of wires. We did this with, so we put nano-coated copper, nano-coated aluminum, and nano-coated copper, and got that running. It works, but it's real hard to measure whether it's stronger or better than the other ones. We've not only have we done this, but we've also done where we've taken the gravitational wires and run them to the gravitational wires from the inner to the gravitational wires of the outer, and the magnetical from the inner to the magnetical of the outer, which is a little bit different configuration. And that unit seems to be pretty strong. But again, it's kind of hard to get a real good measurement, whether it's 2 times as strong or 1.5 times as strong. But nonetheless, oh, and when we did that with the magnetic and gravitational fields, we separated out, or we put different Gans coatings on the gravitationals than we did on the magneticals, trying to, in essence, pull the fields outward. So I just thought I'd share that real quick.
Just wondering, John, did you try just taking a basic voltage measurement out of the leads of that without hooking it up? I wonder if it might generate at least a small amount of power. It's got the potential as a sort of a battery combination, actually. So
yeah, so some of our units have very low voltage that we get from them, but it's nothing to really be substantial.
Like
We've actually done
millivolts
some
or
other
something.
things. We've actually done some other things with some batteries. I don't have good pictures, but uh, where we use some of the different materials in combination, kind of like you're talking about with your capacitors, except trying to make batteries out of them. I don't have good pictures to share of those.
See, Jay had a question during the week. I came across the term plus VE and minus VE. I believe it is to do with ionization, but it's hard to find a good explanation anymore. The plus VE and minus VE are just the plus and minus voltages that are used from, a voltmeter or battery and that kind of thing. I think it's volts electromotive force or something like that. The VE stands for electromotive, I think. Volts, volts, electron volts perhaps, but in an electrical sense. Jay says, in my understanding, the Keshe capacitor doesn't run out as the fields and stuff are kept inside, whereas the Baghdad battery type of capacitor will deplete when it dries out. I'm not sure, is that correct? Well, the way I understand it, the Baghdad battery is more of a battery. It's not really a capacitor. Baghdad battery would be more a chemical type battery, as most of our batteries are, whether it's A or B or C or D cells, or whether it's automotive 12-volt batteries and so on, are chemical process that involves chemistry as far as the transaction between the electrons and the charge involved and so on, with the ions in the solution and whatnot. But the Keshe capacitor is a little different. It has aspects of a battery, aspects of a capacitor, and aspects of an inductor all built into one. So, and it depends a lot on the materials used, depends a lot on its the substance that's used in between the plates that are rolled up and so on. The different materials involved. Okay, what else? How can you make a capacitor give out its charge slowly, like a constant feed or flow, instead of just dumping all of its charge in one go? That's where resistors would come in, and it depends on what kind of system that you're dumping the charge into. If you have a heater coil or something, it can only take so much charge at a time while it will gradually deplete a capacitor. Capacitors are also rated in different ways. The capacitor might have a 250 volt or 2000 volt rating, or a 10 volt rating, which means it'll charge up to that point and won't charge any more of that voltage. So it will it still has a capability of dumping its charge all in one go, like you say, but it will be regulated as to the maximum voltage of its charge. And you can regulate the charge through resistor circuits and different charge regulating circuits and so on. Alright.
Thanks, Rick.
Is there any way to measure the fields with your sound Gans ball and the jack plug device? You could maybe make a note to the distance from the coil and where the ball device picks up the sound or resonance. The distances maybe then could be converted to field strength and so on. Quite possibly, it's a matter of what are we picking up. It's the fields are usually electromagnetic fields that we measure through this jack into the. He's talking about a jack into the. He's talking about a jack into the computer that I can run with. I had an example. Where's my little Gans ball example? I had one here. Just give me a moment. I think it's here we are. This was a sensor that I was playing with. That's this one's actually a CH3 Gans ball, and you can see it has a electrical plug at the bottom, which you can plug a regular phono plug type connection in there, and then the other end can be plugged into a computer as a or into other circuits, but I just plug it directly into my computer, and basically I've got a Gans ball sensor. It's got a wire that goes inside, and some of them I build have a diode built into them as well, but this one I just have a wire that goes straight inside. Nano-coated wire goes inside to the ball, and this little nano-coated coil of wire inside there. So you can pick up on different fields with it. I thought it might be compatible with picking up fields from Gans coated coils and so on. Still needs a bunch of work to work with that idea, but I think Jay has it corrected what he's talking about there. You could use this, for example, I have used it to sense the coils, sense the fields around a coil, or you can put it in the center of the coil and use it as a field sensor.
How about if you put it on your speaker arrangement there and see what happens when you change the vibration?
Yeah, it could be.
That might be
done. Yeah, that could be interesting as well. What if you put ultrasonics into, or even regular sound into a Gans ball? What does that sound like to electromagnetic, or at least a nano-coated wire that goes right into the Gans? What is it hearing? What is it? What do the fields sound like in that environment? So that was kind of the idea with building this sensor. It just requires a little more research and development to actually hook it up and listen to it in many different circumstances and other types and so on, which I've done quite a bit of that. And it is quite interesting, but I don't have major stuff to report in terms of a sensor other than more or less like electromagnetic fields. Each of the sensors that I've built, like this one here is another one. This is the electric test tube. This is the electric ping pong ball, or electric Gans ball. And this is the electric test tube. Again, the same thing that you can plug into the test tube here, and it's got the coil system inside and so on. You can use it as a sensor. Again, it could be used over over maggrav coils or other systems that are set up. I've tried a number of different ways. I've also put a coil around this to try to sense this as a central sensor and sense the fields coming and changing around that. And so on. There's different.
Did you have any results with it?
Well, the results are hard to determine. It's hard to get. Basically, I find it pretty difficult to get Gans to talk. It's it's like it's sitting there and it's got some potency to it, but how do you develop it? And so I'm starting to be convinced that it requires certain conditions to bring out its goodness, you might say, or bring out its It's a specialty. And it might require such a thing as two intersecting fields. It might require, let's say, an electric field going in one direction and a magnetic field going in another direction. Then, bing, it's going to turn on as a super sensitive field detector or a super, generator of power or some sort of effect like that, which could only be under very specific circumstances. We talked about resonance and fields and so on. If you were to consider like the idea of the idea of sonoluminescence inside of a sphere like this, you have to have very specific frequencies, like probably within maybe 30 hertz plus or minus, to get it to resonate at the correct frequency to produce that sonoluminescence. And you could be playing for years with all the wrong frequencies and see absolutely no effect. Nothing, not even the bubbles bouncing around or doing anything. And then suddenly, one day you happen to hit the right frequencies and this thing's glowing and it would be eureka, wow, finally. So this is the sort of thing, I think, that the Gans, we haven't really totally penetrated the world of Gans and how to open it up, how to get that plasma to open up, the fields to open up, and be able to start working with them that way.
How did you attach that device there? Is it just stuck inside the ball and glued?
Well, yeah, what it is this is just a jack, like a standard jack that I found at a radio store, and I've actually glued that to the ping pong ball, and then I ran a tiny wee nano-coated wire from, see if I can get the lighting just right here. You can sort of see it against my face. There's a tiny little wire that runs from one terminal up inside of this. This is actually a piece of insulated wire here. It's a speaker wire, very thick. It's got probably 100 strands coming out on the inside of the ping pong ball, okay? And through it's insulated rubber cover there. You can see the corroded or nano-coated starting to turn a little blue inside there from all the wires. So I got one wire of that whole strand, that whole multi-strand, fine wire, I don't know how you say that, but the what do you call it? The multi-strands of the wire. I took one of those tiny wee ones that's so wee you can't even hardly see it there. You can barely make it out. And it goes into the detector part, the center wire of the plug-in. So essentially the plug-in goes into a multi-stranded thing inside of here, nano-coated stranded wires inside of the Gans liquid. And by the way, I've noticed the Gans liquid is almost like, well, it's about a third missing off the top here compared to the last time I saw this. It's not leaking anywhere. It's interesting. I don't know where that went. But anyway, that's the basic setup that I tried for this one. And like I say, each detector is a little bit different. The one with the test tube, and I made several different test tube ones, and each of them are different. They're different in the way they sound when they pick up the fields, and they're just like a different range. Each one could be used for a different range or different function, depending on if we can find out what the function actually does. Yeah, I used a piece of this wire inside of it. Thick. You can see this is nano-coated as well. You can see the quite well nano-coated, but it's very, very fine wire. It's just I think there's probably 100 strands in it, and this is an example. The wire's completely nano-coated all the way through, and it was just started in some caustic, and was able to travel all the way through, and it's kept that same nano coating for over a year now, just the same as like that.
Very nice.
What else can we say about that? All that stuff. Any other questions or ideas about that?
I'm kind of anxious to see what Mr. Keshe has to say about measuring devices when we go to Rome.
In the science
Yeah.
end of that, yeah, that would be interesting. All right. What are you guys using as measuring devices? Are you still using the? Do I have an example here of the stick? A little detector stick.
Yeah, we use the stick. At least we can tell that we have fields, and in general how strong they are. But it's not 100% accurate. As a matter of fact, if you measure, a foot out from your mag graph, for example, the reality is that it's probably 5 feet out.
Right. Yeah.
Part of the fields.
Yeah, and those. I'm trying to find my device. I can't find it here offhand. I saw it earlier. Where it is now. Anyway, they're basically an electromagnetic field detector. Some of them are called a radiation detector, but I think it's a radiating field essentially. So it might be useful to have. There's other types of detectors. I mean, we have magnetic field detectors, which are available on. I'm going to show my cell phone. There it is. Various detectors. I think I've got one here. I haven't used it in quite a while, actually. Just wanted to show an example. Which one did I have? Can't find my field detector. Oh, there we go. There's one of them that's called a magnet meter. And it's got sort of a little arrow that points to your where the magnetic field is and whatnot. Gives you the microtesla field readings as well, and so on. Can't see it too well there. And then there's other devices. There's a Tesla meter, another one. And it gives sort of a running graph of the fields. Let's see if I grab a magnet. Whoops. You can see what a magnet does when it gets close. In fact, you can see this is the field here. So you can see it's generating a little graph there. When I bring the magnet close, whoops, it overloads when you go too close. So it'll detect
Does it detect gravitational fields also, or just magnetic fields?
Well, that's the thing. We don't have a gravitational field detector as such, unless you were to say something like a seismograph is a gravitational field detector. It measures, changes in the magnetic field of the Earth and that sort of thing. Or we've got seismographs and magnetometers and all kinds of things that'll measure small changes in the Earth's magnetic field, which is happening, in the Earth's gravitational field rather, that is happening all the time just from variances in the core of the Earth as it's rotating and that sort of thing. And there's variances of the gravity even along a flat surface on the Earth, relatively flat, curved surface, but flat in the sense of looking outward. There might be different metals in the Earth. If there's a lot of iron, then it'll tend to have a greater detection of gravity over that area. But as far as the fields that Mr. Keshe talks about, the actual magnetic gravitational fields, I'm not convinced that we can measure the magnetical with our magnetometers. I don't think he's talking about magnetic field. He's talking about magnetical, which is magnetic-like, and it's
The plasma fields.
yeah, and it's a pushing effect. It's the repelling effect of the magnetical.
So
Whereas-
apparently, some of the people like in NASA have devices that they can measure the plasma fields, even though we can't see them. They can measure them. I think like the what do you call it, Carillion photography can measure or see visually show the fields, the energy fields, and I think that the aurora photos are kind of similar to plasma photos. That's my
It makes sense, and you'd think that we'd be able to use some of that technology. Like, what would happen if you took a Kirlian photography of a MagRav unit, for example? Would it show the fields around it? I don't know if anyone's done that. I haven't seen or heard of that being done. But that would be a good experiment, I would think. It should be checked out. And how does you take a Kirlian photograph of someone, for example, and they have a certain aura around their body. What if they were holding a MagRav unit after that, and does it give the same aura, or does it change it in some way? I haven't seen any results from that. That would be good to do. What other means do we have that we might be able to use that are means of detection? I mean, if you think about it, there's probably a dozen different types of detectors in terms of fields. There's your electromagnetic field detectors, which are usually the little pen things that light up. They're electromagnetic field, not necessarily magnetic or electric. And then there's magnetic field detectors, like the iPhone apps that I just showed. And then there's electric field detectors that you can buy, and a little unit about this size that you can use to detect electric fields. That is what we call static fields, which are not really static. It's a misnomer. They're actually dynamic. But what we call a static field, or that potential of that gradient due to static charge, what we call static charge. Interesting. So there's other detectors. For example, my little like one of these things that I built. My spooky Tesla Spirit Radio is called, which is this device, or the other little one that I've hooked up many times, this little guy here. Again, it's a crystal radio circuit, but it's a detector, a broad range detector, which is what's so great about the crystal radio. It goes, I've been able to demonstrate a crystal radio picking up probably a dozen different types of fields, everything from audio, from talking into it, it'll pick up your voice, through to any part of the visual spectrum, right from infrared through to ultraviolet and all the colors in between. It'll pick up light as like a laser light and other types of light. It'll pick up on the radiation coming from the video screen. It'll pick up on the radiation coming from this light bulb in the light. And it'll pick up on the vibes coming out of this amplifier or this speaker right beside it, just directly from the speaker, electrical fields and so on. Electrical motor, anything that sparks gets picking up. It's totally wide range. I think it actually picks up all ranges of the universe. It's just we haven't tuned the circuit to certain ranges that we could specify if we wish to.
You know, it'd be interesting to see what it does with your plasma ball.
Oh, I've worked with that quite a bit actually, and
What does it show? Does it show anything unique with that particular device?
well, yeah, I've shown before. It would take too much time probably to set up right now, but basically if this was the plasma ball, which it is, say that's the plasma ball that's going, well, this will actually detect, what I've found is the plasma ball puts out actually a series of spherical fields. So you'll have one field that's quite close, about this far away. You'll have another field that's about this far away, again circular around the unit, and then another one again a little bit further out. So generally there'll be 3 spherical shells around this being generated all the time, and it'll be a definite place, like within maybe a centimeter difference, where I can move I'll move the well, you can see it better sideways. I move the unit in and out just a couple of centimeters, and it'll make a huge difference. There's like a definite barrier here, and then close, and then further back. And that to me is quite intriguing to discover that, and to actually try to work with it, to work with that barrier, to try to tune it in with the radio very finely, just move it a tiny little bit, because in that barrier, it's a membrane actually. In a way, that's where all the action is. That's where the friction is between the fields. That's where the transition point is. So in the example of the little radio, you'll hear nothing, just the ambient fields, just a little bit of do, and then all of a sudden the closer you get to this membrane, it'll pass through the membrane, and then it'll be a little higher inside that membrane. You come back and it still goes. So, and the same thing up here, down here, all in the spherical shell around this. You can go over here, it's the same, and so it'll have actually a membrane, an actual interface. And to me, this is fascinating. This is where all the action is, if you think about it. I've shown this unit before too. This is also based on crystal radio circuitry, and it's from folks at Brain Power. And yes, brain is spelt differently. It's not our brain that we use in our heads, but it stands for membrane power. In other words, the power to interact or to work with these membranes, to be able to pass through membranes of different dimensions, essentially, is the way it works. And we can learn to pass through into another dimensional space by certain actions that we do. And this is more of a physical example with this plasma field that's generated from a plasma ball. But this field, this interaction, this membrane, it's almost like a physical thing. It's like zoom, zoom, zoom. There's something definitely there. And when you can actually hear it, and the difference, I should actually set it up maybe and try to do it, but it gets, the sounds can be kind of annoying and it's hard to tune in. I have to fiddle with the software for quite a while and get into the whole zone and get everything fine-tuned so I can actually hear it and feel that difference and so on. It would be too time-consuming here right now probably, but I've done that in the past, in one of the past, couple of the past workshops. I'm not sure what the numbers would be.
Rick, this is Denny. He's trying to break in again.
Yeah, hello, Denny.
I got to break the mood. You know that MOSFET, or I don't know, MOSFET. I don't know if you're how to pronounce your name, Mr.
Yeah, that's it. That's you're correct.
Are you ready?
Yeah, I guess I can show, but I have a question for Rick about what he just talked about before we could go. Have you tried changing the speed, whether the membranes that you mentioned, do they move, or is there any change as you mentioned, perhaps Gans or some other parameter of your ball, plasma ball, whether it changes the location or the distance of this membrane that you're talking about?
Well, what I did find was one interesting thing was that I tried a different sensor, like I tried a test tube sensor, for example, and I thought that I would have the exact same place where the membrane was, but a different sensor actually sensed the membrane at a different position. So then I thought, well, that's interesting. Maybe that it's more sensor dependent in a way than an actual objective membrane as such. So so these fields are set up. They're already in membranes, but we don't sense them unless we're tuned to them. So like this particular piece of equipment is tuned to the membrane here, whereas this other test tube piece of equipment senses a membrane maybe a foot behind it or a few centimeters behind it or whatever. So there'll be a difference in that, which I didn't expect initially. I thought it would be more objective. And
one of the things we found out in Arizona, Rick, was that our bodies influence the things that we're touching.
Yes, that's another thing about it.
When we do our little electrical tester, you'll see that we tie it to a stick.
Yes, right.
So that we're not influencing it, because we can actually, our bodies can influence it.
Big time, yeah. Our bodies are probably the biggest thing in any particular room that absorbs electromagnetic waves. I mean, if there's a saying that if you want to measure the radiation in a room, you just measure the humans, because they absorb the radiation. If you got fields that are going on, the human with its water construction and Gans and whatnot is a natural field absorber. And so we have all these fields bouncing around inside of us all the time, because right now in this room there's probably at least 100 radio stations that are coming through, and all kinds of other fields from all the electronics and other modems and other things that are working, not to mention cosmic rays and other outside influences, and maybe a kid screaming is outside is enough to cause other waves happening, and audio waves. And so we get all these waves. We're basically a wave structure. That's what we are sort of designed for in a way, is being a receptor for waves. And that's been discussed before, and ideas like we only get part of our energy from food and actually get most of our energy from the ambient environment. It's another idea that goes along with that. So Jay's mentioning the transition points are like the plates in a capacitor, maybe, or the gap, I mean. Well, I would say the plates are more like the transition points in a way, like the field in between where you sense a field here and the actual unit. What's in between is like the space in between the plates in a way. It's a gradient, and you can actually hear that gradient, and it'll be, you know, a little bit louder as you get closer to the unit, but not necessarily in direct ratio. It's the space in between that's kind of all one sound. You get really close, then the sound increases for that particular barrier that's really close. You'll hear a definite increase in the sound. And then actually, strangely enough, with some of these sensors, when you get really close to the unit where you'd think it'd be the loudest, it actually gets quite quiet, really close to the source. So it's very interesting how that can work sometimes. The plates in a capacitor, well, you have a gradient there, and a capacitor can have a field around it in a sense, but it's a little bit different, I think. Okay, MOSFET, did you have more to your question there, or did it get answered? I'm not sure if I went too far afield there.
Yeah, it got answered. Thank you.
Alrighty.
Was you gonna show something?
Yeah, you want to show us what you had there
Yeah,
before
I
you
was
got
going.
cut out?
Yeah, I'll have to turn on my camera. Hang on a second.
Not sure if you had a bandwidth issue or what happened there before when you cut out.
The internet went away for a little bit. Yeah, I'm in a third world country, so it can happen.
It happens
So,
here in this so-called first world country, which I think it's turning into more third world than first world, actually.
Okay, so I will start. Let me see. So, I was in the US for a while, and now I'm in Bangladesh, and I'm trying to get something fabricated. So one of the things that we are doing is I am fabricating these glass spheres. You can see it, and so I've started doing it from the beginning of January, end of December period. So I'm working with, this is a custom fabrication. It's easy to do here because it's cheaper and there are some very skilled people. So first we tried doing the blowing of the glass ball, and that didn't work out very well. So then we created some mold. And nobody makes things this small. So what happened is that the machines that make bottles, I mean, usually bottles are used for, bottles are the ones, bottle making machines are the one that was initially used to make this, didn't quite work. They couldn't go this small, and and the hand operated one were difficult particularly. So finally we made a machine to press these things together. Still there is some difficulties, but we are very close to the final run, and I have tested it for seals, and actually I tested it in making hydrogen with caustic, and I use those very powerful epoxy glue, and 3 tons per square inch, and it blew, and the ball blew apart and hit the two walls. So anyway, so it works. This is about for internal diameter 2.9 centimeter, 29 millimeter, and outside diameter is 41 millimeter. And this is the first one we tried. So we have to machine to make them uniform. The tolerance is right now 0.5 millimeter. That was good. So we are going to add hydraulics to the machine. So anyway, so that's what's going on in terms of building this. So and then I built this, which is a is just the star formation here. The difference is that I'll try to go a little closer, and you see these black tubes around it. I'm sure. Can you see it, or is it obvious? This is I'm replacing the coils with black tube. It's a nano-coated copper tube. Actually, there.
We see black wires, and we see the what is it, bamboo tubes.
Bamboo. That's the frame. That's frame, because I didn't want to nano-coat anything, so bamboo was a good choice in that. It's readily available.
Yeah.
So this is what I'm talking about. So that sphere.
Oh, I see little tubes around the spheres. Yeah.
The tube. So the tubes are essentially copper tube nano-coated both inside and outside. So if you look at the tube structure of a tube structure, it's discontinuous at the end. So essentially you have two separate nano-coated layers. So it's like having two coils. And if you think in terms of the shape and the structure of it, the flow would be just very similar to the coil structure. Since field flows in every direction, there will be a rotational flow along the axis of the tube, and then it flows just like a magnetic coil. So there are several reasons behind doing this approach. One is that you get very fine layers. So it's like having very fine nano-coated copper wire. I have made earlier like fine wired maggraph coils. So that there will be, I saw one glass ball, so there will be two glass balls. The smaller one, we are making it still. We're doing the first run. We're supposed to get it next week. And once that's ready, and once we have figured out what the concentration of various Gans material we'll put, my thought is to have similar Gans material to the balls in the tubes, so that the tubes couple with the Gans inside, the Gans water or liquid plasma inside, and then try to get the rotation not using motor but either capacitor. There are several ways of doing it. I'll show a little more after I go through this. So we can use these tubes. Like, for example, one of the things that some of you have noticed is that if you rub the tip of a multimeter on top of the nano-coated tube, you get a voltage spike. So in my mind, that spike will create the initial rotation that we need from the motor, and then the rotation can go on after that. So the spike goes, people have seen 1,000 volts, and that's in the electrical domain. So in the plasma domain, it will probably be more. So those are some of my thoughts. Obviously, my thoughts of some of these things are not completely worked out, because there is obviously gaps in our understanding, but some of you may know or have better understanding in many of the things. So that's why I'm kind of presenting this, so that where I don't know anything, you can fill in, and we can all learn by that process.
Okay, nice.
Basically, this is what I would call the drive system. So just hang on a second. I will have to move and show you other things. So that's the drive system, and then we have the ring. So I made the ring. It has some structural problem. I'll bring it further closer. So this is the ring, and it's like 3 nano-coated copper tubes. And let me adjust the camera a little bit. And so the balls can go freely. Right now, there was some structural problem. In one side, it does move, but in the other side, it doesn't. So I have to do some mechanical thing, and I have a design for a sort of like a 12-foot circle of this, which will be much more mechanically rigid. But this one will do the job, and we'll have to adjust a few things, and it will work. So this is, I mean, I'm doing the mechanical part of the design using the sample balls we have created. And I mean, I'll show you the balls a little more close to the camera. Okay, so if you look at the ball, there is right here, there is a ridge where my finger is. So when I connect the two balls, there is a small hole that gets created so that you can inject through that hole. So that's something I just use a grinder to just grind that hole, that ridge where the connection happens. So after we assemble the balls and put aluminums or whatever inside the balls, then we can inject liquid later on, so that we can start the reaction. Let's say we are doing cold caustic in there, and we want to delay the action after we put everything together, things like that. So that's the ball part. We are still in the fabrication process. I will take some of these balls to Rome. That's my plan right now, and I hope to have the small first run of the samples for the small and this size ball. This size ball is done, but the small one is being done right now. But we don't have the machine yet turned into hydraulics, so the tolerance is still that 0.5 millimeter, a little more than 0.5 millimeter this way or that way. So that's our situation. So I have the design for a larger one, but once we have the Gans and other things worked out and see whether all of these work, then I can go to the higher scale model. Higher scale version, bigger scale version. So that's the current thought. So this is where the balls will rotate. And one of the reasons for picking tubes here, nano-coated copper tube here as well, is that first it will be mechanical, the balls will roll, and the friction is less on the nano-coated tube. So that's one of the thoughts in the mechanical sense. But once you fill the tube with Gans material, we can have the magnetic gravitational properties to it, and then the balls will float. And that's the thought. And so we'll have to work all of these out. We are still some ways off for that. But this is the beginning. So these are some of my thoughts and experimentation. Making the balls take a long time and a lot of effort. And this is, I didn't expect this, but we got some of the best people, really. And we may even go into, these glasses are glasses that you get when you make glass bottles. But I'm talking to a glass chemist, and he's saying, I'm talking about making lead glasses so that it has the property that Mr. Keshe has talked about some time back, and we can make these balls with the lead glass composition. But the only difference is that we have to melt our own glass and making in small quantity. So that will require some setup, and it will take a little bit of time. But in the meantime, we can work out the Gans material and various other things, and work out some of the Gans selection, hydrogen production, and carbon production, carbon Gans production, various other things, and see whether we can rotate the balls and all that things. And I will stop at. I'll show you another thing. These rings. Here's an example of.
Just let me stop you just for a second and see if there's any questions or
go ahead.
Comments here as we move along, because it's interesting stuff. For example, when I see these tubes set up this way, I think if you had a superconducting circuit inside those tubes while all this was going on, it would be quite an interesting assembly, all right. And I'm thinking, the tubes would have to be joined so that the balls, when they move around, aren't hitting on the little rubber tubes and so on. It'd be sort of a more...
No, it doesn't hit. It doesn't hit. Right now, No, it
Oh,
doesn't.
it-
It only touches
the-
the nano-coated tube.
The two
Nothing is.
tubes
only,
on the bottom, you mean?
Yeah, the plastic tubes, I mean, I put them for reinforcement because the nano-coated glue, I mean, the simple glue doesn't hold nano-coated tubes very well. So at first I assembled it and, it was falling apart. So then I had to put the reinforcement from outside. So that's that's the reason why I have those. But
Okay.
they won't be there in actuality.
I see.
Like, this is
Okay.
for just to hold it together.
How did you join the tubes together? Are they soldered together or some other way, or?
There is a plastic tube within the tube, and which nicely fit, and you can glue on it, and so and it's inside, so it won't affect, and you can still have liquid plasma flow if you need that. So it should work if we have the liquid plasma within the tube as well.
Possibly, yes. Depends how you look at that.
The joints are very smooth, and I can make it as big as I want. And I have tried a larger version, and it works. So you can join segments of tube and make a fairly large ring.
Right. Interesting. Simple
my
way
idea
to
is
do it.
It's very simple actually. So.
I guess you would have to probably grind the glass to make it perfectly round and smooth to have a good action on it. Is that correct? Or
no, the ball is perfectly round. Actually, it's made from a mold.
Yeah.
And it's perfectly round. There is a little bit, I mean, as I said, a little bit tolerance problem. That's why sometimes we have a little bit of ridges. So that's what we have to get rid of, the tolerance problem.
That's what I was thinking. If you were to grind the ball, you might it might even be cheaper to grind it to at least a 0.1 millimeter tolerance, or even better than that would be better even. Depends how fast the balls have to rotate too. If they really get going, then they'll have to be precise. They'll try to jump off the tracks and whatnot. Yeah, interesting.
Actually, if it's magnetic gravitationally positioned within the track, then actually the tolerance can be lower. I thought about that's an interesting phenomenon. So if we get more advanced, actually our tolerance can go down.
Quite possibly, yeah. If it was floating, then it wouldn't matter, perhaps, so to speak.
Yeah, exactly.
This is Denny.
Go ahead.
What's your guess on how many balls will need to be on the track?
We'll put as many as necessary to get. Right now, this ring is a stool size. I want to ride the stool, so as many as it needs. So that would be my thought.
So you might want an easy enter and exit point.
Yeah, that's actually not that difficult to do. With the 3 rings, one of the small rings that you see here, you can actually open it. They will be connected using a spring mechanism, kind of like Armand's connection. So you can pull it apart, and then you can drop the ball and join it again. So it will be connected at 2 points, and the third point will be spring loaded. Okay. Does that answer your question? Yeah, it should. I mean, it should.
Mine was a simple question, so thanks.
Yeah.
All right, great. Any other questions about that?
I guess nobody understood what I said.
No, I think we got it. No, this is right in line.
These are things that are running into our minds, and I wasn't able to conceive of getting glass balls made to do this, but the track is similar, and I can't remember the guy that made the track before, and I just have a little bit of
Smith. Wasn't his name?
Well, he's not on right now. He usually shows first. What's his name?
Smith.
Not all of us can have a brain loss.
You mean Lee Coates?
Yeah, Lee Coates. He's not on. He usually has to go near the end, and so he made a wooden track for his, and right off the bat, What size of track is your larger track?
The larger one, my plan is to make it 12 foot, 12, 13 foot in that range diameter.
Yes, that's what I was thinking.
How big would the balls be?
It will be the same balls, but the number
Okay.
of balls probably will go up.
Yeah.
So.
That
And your
could get
tube
interesting.
is probably going to be a little bit thicker as well. You're probably going to use a thicker tube. I mean, a bigger diameter tube.
Yeah, it's stiffer tube, not so much. I mean, I don't think size matters a whole lot. We just need to have enough stiffness so that. But I mean, I tried hanging it in a certain way, so it doesn't have to be really that stiff. So you can have sort of like, you see that the bamboo, the tripod, you can have wires from the top of the bamboo tripod going to a bigger ring. Think of it that way, and you can. If you can have multiple wires going, and it holds actually. So you can, these small rings, you can tie at the top of these small rings with if you have enough of these small rings, and you can tie all sides, and it stays. I mean, I mean, some people need to be together to do it, but it can be done.
So may I ask, are you hoping that the balls move on the
Well, I'm not hoping. Actually, a long time back when I was in the US, I did some experiment with Gans material. I had rotations in Gans materials, and I know that rotation is possible. So I haven't, I mean, since I moved, I had to look for things here in Bangladesh, which is a little different than the US. So I know I can create rotation. I mean, I have done it before, so it's not that I'm hoping. I know it's doable. And that was in 2015, I think, around 15 December, somewhere there. So yeah, it's possible. I'm sure it's possible. And I mean, these are the way I view it is these are essentially magnets. If magnets can repel each other and have enough of these magnetic balls in this ring, they will repel each other. And if you can prime one of these and start moving it in one direction, everything else will follow.
Well, you're hoping for a pulsation within the rings.
No, it's not a pulsation. It will be a rotation, I think. I don't think it's a pulsation. You got to
push and pull one way or the other, right? You got to push.
Yeah, it's kind of like a starter motor. You need something at the beginning to get it going, much like in regular balls. If you want to create rotation, the same thing. You have to prime it. Right. So one of the ways to do it by applying electrical voltage, and so right. We'll see how it. I mean, some of these need to be worked out, and we need all the help we can get. I need all the help I can get actually to do it. And so some of these are not clear at this point, but some of these there are some clues actually. Available.
We're just scientists. We're just friends making experiments, but. I just was wondering what your intentions were to fill those tubes. I work with tubes too, so
my intention about tubes, whether they're in the small balls or these, is to essentially now those tubes are holding the ball with the glue. Yes. But it has to be. I mean, it has to be magnetic gravitationally positioned, so the tubes will contain the ball, but it shouldn't touch anything.
No, but what I'm asking you is, what are your intentions to put inside the tubes after you have you
liquid plasma or plasma field? I mean, field plasma, and whether it's in liquid form or some other form, I don't care. As long as I can create the attraction, gravitation, and magnetic field properly, that's all.
Are you going to put a CH3, CO2, or CuO in the tubes?
I am not specific. I know some of the properties of it, but I'm not specific about which GANs. It can be hydrogen and carbon GANs as well. Only those. So one of the things I'm thinking of. I mean, you guys might be able to help me with this one. Is that
have you tried to nano coat those tubes?
They're all nano coated right now, inside and outside.
How did you do? What was your process in doing that?
I did it with caustic methods. I have tried other methods. I mean, like the fire coated. I don't like it at all.
You
So
fire coat a plastic tube. So how did you nano coat that tube?
the plastic tubes are easy. You can just put it in caustic and they'll nano coat. I mean, I've done it many times actually.
So you just soaked it in caustic?
Yeah, soaked it in caustic, and then dry it, and you do it several times. And
did you rinse it? Did you rinse it at all?
At the end you rinse it.
Okay, so it was a clean after. So you determined that once you put it in the caustic solution, the vinyl tubing changed resonance. You feel that something has changed within the plastic tube in order to move energy within the tube.
Yeah, that's true.
Okay, so within the tube, are you planning on putting anything inside the tube?
I'm not using plastic tube for the main purpose. It's just right now I'm using a little bit to just create support, but in actual design, there is no plastic tube. It's all will be copper nano-coated tube. And so I don't intend to use plastic tube, although I have built stuff with plastic tubes before. So that's my current thought. It may change depending on how things work out.
Oh, okay. Well, thank you.
Yes, this is your prototype for your.
Yeah, I mean, this is to work out some of the mechanical aspect of it, and then as we start to put Gans, then we'll start to see actually the dynamics come into play.
Maybe if I could share again, I'll show you mine.
Okay, I'll stop. Let's see.
And maybe by showing you mine, it might open up some possibilities for you in terms of your thinking.
Thank you,
All right,
Masvak.
that will be great.
Thank you, Masvak. Very nice work there.
It was very nice.
I like your work.
A lot of thought went into it.
And you're a lot closer to what's going on in whatever secret parts of the Keshe Foundation than you realize, I think, too, with that design. So there's a little hint.
I'm not listening to any secrets. Somebody may kill me.
That's right. I didn't say any.
Okay, so what we did here is we have, these were 3D printed. We have, in terms of, Denny, I think you brought up the number of balls to put inside. I think you want to keep them in the increments of 3, 6, 9. Mr. Keshe mentioned 36 as being ideal. In this particular one that we built, we're putting 9 in there, 9 40mm balls inside. These two half of the spaceship kind of clamp down here together, and then they freely spin and attract inside. This particular thing here, it actually rotates like a lazy Susan on bearings. So what needs to happen is you need to have that initial impetus of motion to get started. Whether it's an actual motor that turns it, we're going to try to do ours by hand, by spinning them. We're going to have 3 reactors on the outside edges of the internal spaceship. You can see the little reactors. We're going to just put them, we have these little cups you can see down here where they're on the little, these are the motors with the hard drive motors. We'll put these little cups here, and we'll put the 40mm balls with a 20mm ball inside of that. And these will spin. We'll have 4 of them, 3 on the bottom, and then 1 up here on the top. Now you want to get your spin to go anti-clockwise is your spin. Because anti-clockwise is your magnetical fields. And that's really what we're looking for here is magnetical fields, stronger magnetical fields. So I don't know if does that help any, or is that?
Yeah, that definitely
That's-
definitely does.
Well,
So-
you could go ahead, Rick.
I was going to ask, what were in the Gans balls that you had in the center again? Were you going to try different combinations? Is that the idea?
So again, this issue of mass ratio is the key. So what we're going to put in there is, okay, so we think, or at least I think, that I've actually created some hydrogen GANs, but I can't prove it unless we start spinning them. And when we spin them, we'll find out how true it is or not true it is. We're going to put the hydrogen GANs, a small quantity on the inner side ball, and we're going to put a little bit larger quantity on the outside ball with some carbon GANs. As we know, carbon is their connector, and they'll connect to the other fields. That's what we're going to try.
Hey, John, I have a question about this carbon. Have you been able to make carbon GANs?
Oh, sure. Carbon GANs is pretty easy.
How do you make it? I've never heard of this one.
Well, okay, so we do it two different ways. You can use a shungite, which is a very high concentration of carbon. You can use a shungite stick with a carbon stick, or you can use carbon stick and carbon stick. Put one on the positive, one on the negative, and put it in salt water and put your power up a little bit higher than you would normally. Maybe about 7
Volts?
7 volts. Yeah.
Wow.
That's
it?
Do it so it doesn't cook it. Just kind of figure out when you see the reaction, what point you see the reaction.
And you get a black material then, or?
It kind of boils off. Let me see. Well, okay, I got it. Well, I don't want to share. I have to find the picture. But yeah, it just boils off, and it'll be a black material. Yes.
Mm-hmm.
Has anybody thought about separating out the C from the CH3 using the zinc copper field, which is essentially a carbon field?
I don't know if anybody else picked up on it, but I sure did.
Yeah, I was wondering whether anybody has done it. I'm curious because that you can do in a ball even.
So last week, Mr. Keshe gave us a very important clue. If you were listening for it, or maybe it wasn't last week's thing. Maybe it was in a different conversation.
You have private and secret conversations, so
So
no. Anyway, go ahead.
Remember how we make the hemoglobin GANs, where we put the copper, nano-coated copper, and a zinc plate to start off, and we start to make CO2, and then we add in the iron, okay, to make hemoglobin GANs. Is everybody with me on that?
Yeah,
Okay.
that was mentioned.
Yeah, we do that.
Okay, in some cases, what happens when you're making that hemoglobin GANs is every once in a while you come up with a batch that looks completely different, where you actually get a white material that, or I'll call it a yellowish white material that falls down in the bottom while you're making what you think is CH3 or hemoglobin GANs. Let me put it that way. So Mr. Keshe mentioned that when he was making the CH or the hemoglobin, that he actually found that he was making inadvertently, not on purpose, but he's actually making the GANs of deuterium, and it was actually that white stuff that that fell to the middle part of the thing. We had a situation where we actually made a bunch of I've seen what he's talking about, exactly what he's talking about. But we ended up mixing it in with our other hemoglobin, and we didn't separate it out because that, in fact, he said was the Gans of deuterium. We just didn't know what it is that we had. That's why, as we get to the point of measuring some of this stuff with spectrometers and such, we'll start to find out that maybe some of this stuff that we're creating is our solution, and it's staring us right in the face, but we just don't know what it is that we're dealing with, other than in generalities.
So, Rick, you don't have a picture up.
Denny, I'll start my video. Gives somebody something to look at. And
so I did that carbon.
On the screen.
I did that carbon Gans. Tried to make it. I was in the process of trying to make diamonds, and when I started to make it, I had these beautiful little sparkly, bright diamond-looking things that were in the bottom of my glass jug. It was about a 1.5 gallon jug, and I was getting all excited, and I said, boy, those look beautiful. Boy, those look beautiful. Look at all those. And then I kept, that can't be diamond. Let's see if I can pop one of those. It was not a diamond. And then I got all this dark water boiling up, and I look, and my one of my electrodes had been eaten up. They were these air arc electrodes. I forget. And
for cutting, for arc cutting, right?
Yes, and they're pretty nice electrodes. They do a lot of things, but I don't even know what I have now. I was about ready to just give it up. I still have it in some jars, and it was a long time ago that I did the experiment. But I was getting all excited. There's such a beautiful little crystals that were forming.
What happened to the crystals when you poked at them? They just shattered, or?
No, they were air.
They were just air. But they looked like diamonds.
Oh,
like
they just glistened in the blackness of that. Well, first the water's clear, and their black was forming on the bottom, and then there was little crystals forming in that black, and it was very beautiful. And I've got to get back onto the right track here. So, John, when you're doing this and you're rotating your balls, the whole point is to try to build an outside skin of your ship. Is that not what we're after?
That's correct. That's why we put in the carbon Gans.
And the hydrogen. That's what we're after, so that we can build any kind of skin that we want when we want it. So
I don't know that we've got the full solution. He mentioned trying to put like a calcium type Gans in there also.
Well, you know what I've seen recently that I was really shocked and surprised about. I don't want to show the website because I don't do that without permission and stuff. But if you go to what would it be called? I think I saved the site here. But I got really excited about it actually, and what it is briefly. I don't know if I can find it offhand. Let me just see if I can here. Just give me a second. But briefly, the idea is to grow a wall that's the idea that I came up with. And what they're now growing, the fastest growing material that they've recently come up with, I can't find the link. I will have to look it up on
Whose picture is
Google.
this?
This is my
This
picture.
is John. Maybe he can explain that while I look
Let
up
me
what
explain it
I'm
real
talking
quick.
about.
So
Yeah.
remember I was talking about the hemoglobin Gans? This is a nano-coated copper plate here, a zinc plate here, and we use an iron horseshoe. So this is our iron in there. So normally we would have this orangish color material throughout our process. But in this case, it appears like the hydrogen bond here is different in that the color has changed dramatically. And this was the only one that it happened to. Mr. Keshe was mentioning that it happened to him also, and that he could tell by looking at the color that what it was he created was deuterium Gans. We ended up mixing this, but I'm of the opinion that we in fact had deuterium Gans, and we should have saved it. So I just shared that.
Well, one of the situations there, you got your horseshoe upside down. The luck ran out of it.
Well, depends which way you look at the horseshoe, I guess. If you're looking from the top down or the bottom up. Let me see. I'm trying to get back to the original article, but anyways, I can't find it. Here's the idea anyway. Where's it? Just a second here. I just had what I was looking for. Yeah, there's the name. The name of the company is called MycoWorks. MycoWorks at mycoworks.com. And they work with mycelium. And mycelium, let me get my spotlight, my video here. They work with mycelium, MycoWorks it's called, and there's probably others doing it as well. But they take, mycelium is like mushrooms grow out of the mycelium that is it's like their root network that runs, it can run across an entire field. In fact, they found some mycelium networks there that are kilometers long. And it's actually all one being. It's all one plant, one DNA, one plant. And it pops up as all these mushrooms all over in the field, but it's underground is much more massive than the little mushrooms that you see popping up. And this mycelium grows very quickly, and it threads its way through the soil and so on. So what they're doing is they found a way to make leather like material out of this mycelium. And they have a little video that you can see in YouTube and so on, that actually they explain the difference between a cow hide that takes 2 years or longer to grow that particular so many square meters of cowhide, and with this mycelium leather, this mushroom leather, they're able to grow the same amount in 2 weeks instead of 2 years. And they remind us that this material grows so rapidly, it's just incredible. They say all it needs is like 4 different factors. I think it's the right atmosphere conditions, the right temperature, the right humidity, and the right nutrients. and bingo, you grow it. And they have designer leather. You can have any kind of design that you want them to grow in, and you can add materials to the mycelium as it grows, and it will incorporate those materials into your mycelium. So in effect, I'm thinking, this is my brainstorm about this, is that one could, like, they're making furniture out of this stuff. It's so durable and tough. They made a seat, a complete seat, other than the legs they made out of some recycled wood. They made the rest of the entire seat out of this grown mycelium. They actually grow a seat, just like we're talking about in the spaceship, to grow the furniture, to grow the walls. Okay, so what I'm thinking is, if you combine the idea of let me plug in this guy just for effect here. Like, we're talking about the fields generated from a plasma ball or other plasma, let's say, and all right, there it goes. And so we know that at certain points there's like a spherical field around this, another spherical field, another spherical field. All right, well, what if that spherical field, that membrane, if we had the brain power to figure this out, then we would know about membranes, okay? And that at that certain membrane point, let's say you're on this table here, the membrane, spherical membrane comes over to this point. Well, what if we had that mycelium material all ready to go in this sort of puddle? It could be just a pool around the whole center core generator of fields. And what if that mycelium either naturally took to the fields, that's where it wanted to grow, that's where its optimum growth factors all came together, so it just wanted to grow right up on that spherical or whatever shaped field that we create. It will follow that, so that within say a week or two period, you could grow the entire skin for your spaceship, and interior walls and other parts that were required, and according to, like, perhaps 3 spheres could be grown at once with this triple field configuration. If you put two of these together, it creates a different field intersection, and maybe you could also alter the width and so on. So you've got this. Here's the idea: is that you can create, say this is one field of mycelium around the core here. You created that one barrier, and then maybe another one further out, and so on. And so the idea is that you've got that mycelium as a more or less a core. It's bendable, but yet it's rigid, and it's like they make leather into many rigid things. Like a leather saddle is very tough and rigid. It's almost like plastic, basically.
There are people using this mycelium for wood panel, in placement of wood panels. They use it for packing materials because it molds around things, and it's cheaper and light. And the fact that the mycelium actually acts like an insulator, that's why they can use it.
Exactly. And as a microcide, and what do you call it? Bio. It won't.
Things don't want to eat it.
Don't want to eat it and don't grow in it. It will not support mold. It will not support biological life other than itself. It is not alive exactly, but it's like copper. Copper is also the first material approved by the is it the FDA? Yeah, the FDA Food and Drug Administration, or is it the EPA, as a what do you call it? Microcide, I believe it's called. It kills microbes. Stainless steel does not kill microbes, whereas copper does, and that's what's been recognized by the federal agencies at this point, just a couple of years ago. So, anyways, what if you could grow?
Yeah, you look at those as membranes, and that could require that's probably right. I look at it as the atmospheres.
Yes. But
And
also, it's like a bubble, like a soap bubble
Right.
in a way, is a membrane, but it contains its own atmosphere inside, right? So that membrane, in this case, if it's got the mycelium with other things growing in it, what if you grew copper in one layer, and what if you grew, I don't know, neodymium or some other rare material or some other thing that needed to be part of that. It's always going to be a 3-layer skin, right? A 3-layer effect.
Yeah.
So the
One of the
mycelium be one of those layers, but it'll support the other ones and allow it to grow according to its shape, because it's going to want to follow the life energy field. That's the interface of where that membrane ends up being. It's
one of these ticklish points in our developmental stages is that star formation and making that free plasma. We really haven't graduated in that area sufficient enough yet. Once that free plasma is understood and created quite well, then also the fields and the membranes around it, and those balls that are circulating around in that track, they're like satellites, and your walls are set up where they're stationary and they're not circulating around. And what you're trying to form with that circulating ball is you're trying to form 3 skins and your protection for your flight system, and your other reactors that you have are set up for different wall partitions. And of course, we're still trying to figure out, and that's where Thomas, he's looking at the health systems. We're still trying to figure out the health systems, the food systems that we're going to be putting in this spaceship. And so as we look at this reactor with the carbon and the hydrogen, there's all the combinations that you need for food and health. And so it's being, like you say, you're talking about building the walls. You're also you got the plasma speeded up, then you got to slow it down in certain respects to make the oh, for crying out loud, to make the solid elements.
Yeah, well, one of the interesting things is that I discovered with this fungus wall concept, which is the mycelium, or the mushroom. Essentially, it was mycelium. They grow it in bags, right? It can feed off of waste products, which is the beauty of it. It's they use sawdust, they use wood chips or other corn husks or grain husks or other such thing. They can even grow on human excrement. So think about it. It's not such a bad idea to you're growing your spaceship from your own shit, essentially, which is actually, what a grand idea. What are you going to do with all the shit otherwise? It should be recycled. It should be part, that's the ultimate organic way to do things, an organic spaceship grown from its own waste debris, all the stuff that just gets recycled automatically by these little tiny organisms according to our command. And they're happy to do the job. It's like they're getting fed. They're like in their prime, and we make all the conditions so prime for them that they're totally happy growing, maybe a spaceship in a night instead of in 2 weeks, because I'm sure it can be optimized to that degree.
You're not letting me tell you the old joke. The old joke is you're treating me like a mushroom. You're keeping me in the dark and you're feeding me full of horse manure.
Yeah, well, we're all in the dark in that regard, but even if we had light, it's still the blind lead the blind.
Yeah, so that's how you grow your mushrooms. You keep them in the dark and you feed them horse manure.
Well, what do we have in space? We have lots of dark. And with everybody on board, I'm sure there's lots of horse manure to go around.
Yeah, at least most people say BS.
Yeah, BS is good.
There's a lot of BS there.
Like maybe that's actually interesting that you mentioned that. We call it BS, and maybe that's.
There's enough said by me. There's enough said by me.
Think about it. The humans, humans are full of BS. That's what we're really good at. But in space, when you're with a certain group that you might be doing a world tour, and I'm not talking about this world, then perhaps that BS could be recycled in the same way as the other BS that the mushrooms take care of. And again, it becomes part of your protective layering, that all those parts that come up within a group environment, the BS that goes on and so on, that negative energy, negative emotion, can be turned into a positive by breaking it down and using the breakdown component parts in the same way that a mushroom breaks things down and uses the component parts. It totally breaks down you can see how they have this sawdust set up in the bag, and within a couple of days, this mycelium has eaten right into the sawdust, broken it up, and is now into making it sort of into soil, and the mycelium, the white mycelium, it's white material again, just goes crazy all through this, and it loves eating it up.
Hi guys, it's Tom.
Hi Tom, how you doing?
Very well, thank you. You guys, especially you, Rick, a few minutes ago, you just talked about the shielding made by the lava lamp, or potentially lava lamp. And we got here a very interesting history. I mean, very interesting stories. I know, maybe a few months ago, when we built a few magraphs with my mates, and we just finished all the magraphs was like 5, maybe 6 machines, something like that. And he actually decided to do something completely, not exactly weird, like a completely crazy magraph or some really revolutionary idea. That was basically he basically split the capacitors to the 2 pieces. The one piece was on the bottom, one on the top, and the magraph coils inside. And then all the system, because actually all this magraphs what we done was counterclockwise. So this one was on the opposite direction. And when we connect this stuff all together, was like no any rotating bolts, no any mechanical element, nothing like that. Everything was solid state, and the field was extraordinary. And we get feeling like we're basically underwater. All the floor is underwater, and when you go downstairs, middle of the stairs, you get this I don't know how to explain that. It was like in a science fiction movie. It was so heavy field. You middle of the stair, you just feel it like you just jump to the swimming pool or something like that. It was not the wet, it was not the tension like that, but was like a different atmosphere, a different everything was different, and the sound was completely different. Everything inside the field was quiet, like I don't know. It's not typical thing was you able to find normally. It is a different type of quiet. And
did you
the
feel
field was enormous.
good? Would you say you felt good or bad in that space? Like John
Fantastic.
mentioned earlier that he had the setup with the magravs and so on, and that people felt good when they entered into the space. They couldn't, you know, put their finger on it, but they felt good. They know they felt good. Is that the way that people felt, or was it more heavy, like, ew, this is kind of heavy, kind of thing?
No, feeling was fantastic. Feeling was fantastic. Knowing about feeling. I mean, no one liked to leave the floor because the atmosphere and this different environment was amazing. And I want to just connect the dots because you just mentioned like two lava lamps, two fields. So, and after this experiment, because this maggraph go to some person anyway, we actually disconnect everything and the field disappear, and it was happening in the middle of the night. And after then we just try, because we completely, for the excitement was so big, and we completely forgot to do any notes, anything like that, even the photography, to actually keep the information what we got here was actually made the field. And it was kind of stupid idea, don't do any notes. But anyway, after then we decided, because the feeling was so good, and after I don't know, maybe 2-3 weeks, we just started feel lonely, like we were without this field. Like, where's the lovely field? Where's the place? And I was start experiments how to actually build this field using the minimum stuff. So apart of create some, like, I don't know, 10, 12, 100 maggraphs. So let's try to do this inside the one machine, or inside the only 3 machines, and between the 3 machines, for example. And actually now, finally, I got 2 crazy maggraphs, and they built in a different way. They actually like a mirror, one maggraph is like a mirror picture for other one. It's like a reverse, absolutely 100%.
Thomas, do you have any pictures?
Yeah, I got this in my desk.
Yeah.
Because
sorry, Mark.
Yeah, good idea.
This
It's
machine
best to
they
show
already done.
something.
Okay, I'll switch camera. Okay, guys, give me a second. I need to actually find some correct tripod for the camera, because always same story. I'll try today do something different. Stabilize camera. That's gonna be progress. Main progress.
Mark, how's your time working for you?
Just thinking, I know you want to show us something there, Mark.
Well, you may have to get up too early tomorrow, so I was just wondering.
All right. Okay. And that's I just decompose now a little bit, because it's not ready yet, maybe before nano coating. Okay, I'm gonna decompose all this construction to show you the new idea how I like to build all these fields again. The one machine makes counterclockwise, the other opposite direction. So, and I try actually make this field bigger, definitely bigger than normal maggraphs. So the solution was quite basic. And this is my Lego box. And this is the.
Your video is stalled there. Now we're back. Yeah, we're having a bandwidth.
You're back, Rick. You're back, but he's not. And
I'm gonna take off my video. Maybe it'll help with the bandwidth. I'm not sure there. We're only getting spotty.
Right.
I'm only getting occasional pictures of your thing, Thomas.
Okay, I got for a few seconds same problem with hearing you. Maybe that was only for seconds. Maybe now gonna be better. Maggraphs help me. Help build the connection.
We see you.
We see it now pretty good.
All right, I didn't get any
Not
pointer. I just missing kind of special pointer, like on the all documentaries movie, like educational movie to the school, like hey kids, and with the arrow. So anyway, I'm gonna use the stick. So that's the main heart for the system. The capacitors, of course, downstairs. Oh, it's all the stuff. You know, that's important. I'm gonna let for now. The most important is this floor. This is a reactor, and the reactor is connect to through the capacitors basically. And I'm gonna disconnect now. Okay.
Could I ask you, Thomas, how you made your capacitor?
I did a few different types, and those machines get new, let's say, kind of prototype for old ideas with the new look, and I will draw on a few seconds after then if you like to know how I build all this stuff. I'm gonna do a quick sketch, much more clean and easy to understand. All right, that's both capacitors. I'm gonna skip the capacitors for now. So the most important thing is attract the field inside the stacker. And this is my, as you see, this is the ball inside, and finally gonna be reactor inside. This is the prototype version. I got only one core, which is not the best. I mean, not the best idea. They should be double core inside, but for the prototype purpose, I just try to speed up all the processes and decide, okay, let's try with one core on the start. The next one gonna be double core. It's not a big deal to replace and check another opportunity. So this is the idea. Connected core inside.
Is your resin in that ball too?
Yeah. The finally will be resin. Finally will be something like, I didn't get now. I got only ball without no any reactor inside. Something like this.
Does that, when you make that resin, is there a melting point? Once you have, are you concerned about any of the melting? At one time you were concerned about the hot melt glue. This resin seems to melt at a higher temperature.
Depends of components, because the wax get lower temperature, and the other component get higher temperature. So you need to find kind of right moment to don't burn your wax, and everything will be fine. If you like to connect with the hot glue, it's fantastic. It's so easy, because the temperature for the hot glue is pretty much the same like for the composite material. So you just need one drop hot glue, and they just like melt together. So it's easy to connect all the substances together without no any problem. So
Well,
that's the idea. Yeah.
In the U.S. here, we have a couple different wattages of degrees of glue that we use: 30 watt, 50 watt, and 80 watt.
It's the same here in England. I use the industrial one, the 100 probably. This is the big ones, the 100.
100 watt? You're using 100 watt gun to melt the glue?
Yeah, yes. I got two, because you got a few different standards. You got the small one, bigger one, and kind of industrial one, the giant one. And this is not even 100, it's 150. It's really solid one. You need to be careful, because if you're gonna leave the pistol for the long time, it's easy to burn the glue inside the spike. You need to be carefully sometimes, and remember, I will switch off all this equipment if you don't use. So this is the idea. First floor and the next floor, and yeah, and this is the one stacker, and the next one is in opposite direction. So because like I mentioned before, really missing for this field. The field was amazing. They take us to a completely different dimension. Basically, that was fantastic feeling, and the gravitation was completely different. Was lighter, and was very very easy to feel this difference between normal gravitation and the gravitation on the floor when we actually managed when we made this field, and was so strong. So let's try what's gonna happen with this device, because this is the first one. I mean, this is the one machine, and that's gonna be the second machine, and they will work together in a conjunction. Bigger distance gonna be better. So this is two prototypes.
So what was it that this is Denny Thomas. So what was it that you noticed about this stacker that was different than any other stacker?
The difference, I mean, was different. Actually, not many things.
I meant it by the construction of it, other than, I mean, all the connections are the same as a regular stacker, and
yeah. So, I mean, a part of the reactor inside, because the reactor is connected to the minus. So the coils go to the plus, and like you got capacitors inside of batteries. And mostly use combination between the two capacitors, two batteries, something like that on the one side, and I duplicate same idea for the other side. So when you get through the system, you got first battery capacitor, and when you get out from the system, from the coils, you got the second one. So this is the idea. We was check. I mean, after the story with the stacker was long. Take a long time check what actually made these fields, and I was check the capacitors on the top. We actually built the extra model with we just split the capacitors, one part on the bottom, another part on the top, but was not the solution, was not the field. And after, because we completely forgot what actually we.
Hello, Thomas. This is Mark from Detroit.
With the stacker.
May I ask you where the your battery capacitor is located? Your battery capacitor.
On the bottom. On the bottom. Get all the floor. That's the. I always joking. This is my electronic system.
That's where you're going to hold the power.
Yeah, exactly. Everything happened on the downstairs, the lower floor.
Those triple core, four cores.
I mean, it's weird because the core actually the core is triple. The capacitors, I mean, this part like a coil is triple too. Yes. It's like overgrowing. Is like I don't know, muscle cars basically.
What? Pardon me.
Like a muscle car.
A muscle car, but yeah. How does that hold in a battery capacitor situation? How does a triple core coated, nano coated, and Gans coated give and you know what I'm saying is, where does the energy come from? Is, you know, like your idea is telling us that that's coming from a 4-core.
All right. Give me a second. I will draw on the screen, because it's gonna be much more easy to show you for how I actually load all these things with the Ganses and all the stuff. Because normally you didn't see too much because everything is.
Well, I'm just asking you.
Tied up.
You don't have to draw it or anything. I'm just asking you, where is the separation point between the three? Yes.
The separation point is, for example, Ganses between these both parts inside the capacitor, but between the rods and other parts. For example,
how would you keep the three?
Okay, you get one part.
Yes.
I just need more light. Let's do it like that. Okay, that's the first part. It's not finished. It's only under construction, basically. And that's for example something always between. So all right. The transmission point is always between. So paper, correct combination of Ganses, and that's the one transmission point. The next one, because this is only capacitor, as you see, no any elements of battery. Finally, between two dots in the middle, I get battery. This one, those two on the edge, the first and the last one, that's capacitors. On the middle, your battery. I mean, you didn't see now because they unfinished, basically. So I can show you for now. Already working. I mean, ready done machine, because it's on nano coating process. It's one of the prototypes how to match all the stuff together. and the best way. So, but the working prototype for this machine, because this is the bigger version, they're ready to go, they're ready to nano code, and the check was actually happen, and I gonna get this field or not. And this is the normal, this is the smaller version. I'll show you. This is the, okay, I don't want to try put my head, and okay, I got something. And this is the fully working machine inside the electric grid at home. Okay, and that was the first stage to do reactor inside. I don't know they're gonna be visible because it's a smaller maggraph, is a different size. It's like a fractal mathematics. This is basically maggraph scale. I just scaled him 1 of 3. This is the 54 inside, 100, how many, 100 something outside. I got some of the numbers. I didn't remember now. But this is the one of.
Is that one line in, one line out?
I'll show you. But this is the prototype for the different capacitor, because I just try to make everything smaller, and everything drive on the one actually battery capacitor. This is only one battery capacitor on the bottom, nothing more. And as you see, I don't know, they're gonna be visible, and as you see the sun inside, and it's not typical sun because this is the reactor, but still the same problem because this is the single core, and they suppose it should be double core inside. So,
no, but a single core is a good, but what I don't know. I'm asking you is, like, you started from one end and it continues from one end to the other. A single core is what you're saying. So I'm asking you, is it a from one end in to one end out?
It's something like that. I mean, not exactly, because the way how I connect capacitor is a little bit different. I mean, but yeah, actually, it's pretty much what you say. It's like the signal come to the system, go around the system, and go out. So this is like yeah.
So that would be one positive charge in through the system, and then charged up and then back out through this.
Yeah. Let's imagine yourself the coils are connected to through the plus, and reactor inside is connected to the minus. It's like an opposite situation. I use the electricity current and the you know, a kind of differentiation, something like that.
Yes.
They help me build the interaction between.
So you do have a neutral or a negative line connected to that?
Yeah. Negative line is inside the stacker, is inside the sun. That's the reactor inside. That's the negative line. And the positive line, which is plus, go through the coils, and this small capacitor actually disconnect all the signals. I mean, not the disconnect, but distribute across the stackers. So the outside part of capacitor go through the coils, inside the part part of capacitor, which is core, go through the reactor inside. So that was the first small prototypes. I was especially actually build this stuff with the smaller coils to actually check how they're gonna behave. And also this is the different type of nano coating, because that was the magnesium salt inside the solution, and that's the shiny coils. And the effect is quite, I don't gonna say spectacular, after especially after when I get
but it is working right now though, right?
Feels bad. Yeah. It's fully working right now. Is the funny thing, they start the reduction on the small currents, which is very good, which is mean everything is fine, everything is correct. And this is the mass. Don't worry about that. This is just ground signal. I just do something like that to connect the ground line, because in England is a issue with the yellow line always.
So your yellow line comes in from your outside power.
Exactly. I mean, in England, because we got 3 lines always, and many devices use 3 lines. It's not like on a continent in Europe, for example, when you got also 3 lines, but mostly devices use only 2, and your plug is only with the 2 mostly. But in England, it's a different story. The many devices seriously use the ground system.
Getting a free line of energy from somewhere in that yellow line, and you're sending it through the mag-rev coils, and it's coming out through that black line.
This is like a separate line. The yellow one is like a separate line. I always connect with magraphs, with nano-coated and gansed some elements, some coils and stuff like that. But this is like an external line, and I think about this line always like this is like extra support. You know, this is like a wireless support for all this installation. I load them with the plasma, and they help with these two lines.
What kind of Gans did you use on those black coils, did you say?
Not yet. But wait a moment, I will finish the story. No. I got Ganses. Of course, I got Ganses. I got special composition of Ganses. I mean, this one is a quite
special composition of Ganses. We're not supposed to know what's on there.
The special composition means the main idea is same
there's
like
no main
blueprint.
idea because we're all a group that shares every idea.
Okay. But I talk about main idea from blueprint. So the same what you got on the blueprint. So this is the CO2, CuO, and CH3. So same like on the blueprint, but with the
Thomas,
oil.
I'm starting to put Ganses on my materials right now, so I'm just trying to formulate an idea of where I should put my Ganses on my coils, and I'm just trying to ask you.
All right, I use a different kind, not a different. I use this philosophy with the acidic and alkalic. That's the very important for me. That's the way of thinking for my mind. And always when I do the Ganses, I try use this sort of combination between acidic and alkalic.
Yes, I'm very familiar with that. But I'm
exactly
just
so the concept is
put the CH3 in the middle. Did you put it in the top?
No, Mark. The concept is pretty much. The concept is extremely basic. It's like a human body. We always traveling around the same spot. The human body, how we are built. So inside we got the belly. The belly is a acidic condition.
I understand that, Thomas.
Okay, so the inside coil, the inside coil, when you get two coils, always, I don't want to show. So when you get the coil, the inside with this system is acidic. The outside, the magnetical, is alkalic. So, but all the
is what I'm asking.
All right, and normally. I was using just normal combination without no any special, any special things. So the CO2 on the top, copper, which means CuO on the middle, and on the bottom CH3. So, but it's not all. And extra, I got, for example, sugar Gans made by this acid. I was made in acidic condition. Was acids and the sugar Gans get a lot of energy and get acidic condition. So especially if you got Ganses from food, from plants, all this stuff, and made with acid. So that's very important. And the sugar Gans
important, but we just like to know the sequence in which.
Okay, let me finish. Okay, and inside. You get the sugar, I get extra Gans on the coil. I do difference between the external and internal coil. So external is alkalic, internal is acidic. That's the point. So whatever you got, because I got my Ganses. I mean, you don't need to use same Ganses. It's not about this. It's more about what you got. And if you got some Ganses, which you mentioned, made in an acidic condition, so use them on the middle. So you got your heavy gravitational spot on the middle. So you basically attract everything to the middle. So that's the point. I mean, the gravitational fields and the magnetic field gets more easiness to go out. So I was trying with this machine. And I will scale this machine down by 1/3. And the very interesting things with this stuff, the field is really strong. It's very easy to compare to normal fully working, fully built magraph, the bigger coils and stuff like that. So that's look like all the ideas work fantastic. So I got smaller stacker, smaller coils, and they make pretty much same capacity, let's say capacity of field, like a normal bigger one. But that was the prototype. Finally gonna be the, I just want to show you guys the bigger ones. So I was try this idea exactly with this core inside, and looks fantastic and behave very well. It's very fresh machine. It got now 1 week already. And so we're gonna check what's gonna happen next. Everything is working condition, everything is fine, and that was the prototype. And one interesting thing, the capacitor, that was actually make me happy. There's stuff on the bottom. The one capacitor is able to actually do all this job for the stacker, which actually make me really happy. But this capacitor is a little bit different story, because it's 100% tunneling effect. You didn't see because it's black now, but it's huge gap on the inside the core. The core is not the solid; it's empty inside. It's like a 3 when you get, I don't know, piece of metal shaft, 3 millimeter diameter, something like that, and you're gonna do the coil top of this rod. You get this kind of heavy tunnel, the 3 millimeter space inside. So that was the idea for this capacitor, to make them completely empty inside, and make only place for interaction inside the Earth. I mean, inside the space, basically. Not on the copper wire, but somewhere on the middle, the empty space inside. So that was the prototype and worked very well. But of course, it actually made with the same direction like other magraphs, so I didn't get this extra effect I'm looking for. I think the two other magraphs, which I built them with the kind of like a mirror pictures. I think maybe that's gonna be this happy field. I mean, because that was
So
actually
Thomas,
yeah.
Thomas, on your happy field, your heavy far out field, you boiled it down to the reactor is the main principle that created that heavy far out field.
I think the principle was actually field made generally by all stacker. Was not actually differentiation between the capacitors and on the top, on the bottom, or coils and stuff like that. I mean, it was whole unit, and the whole unit generate in. But this is very important in conjunction with other units, then create this field. That was the conjunction between two fields, and that's what I'm looking for. So I was spent last month do the tests and check what's gonna happen if I'm gonna put capacitors on the top. What's gonna happen if I'm gonna put on the bottom? What's gonna happen if I'm gonna do other things? So in the middle of the time, this idea with reactor inside starts, and after short tests, like for example with this stacker, I was discovered the field is really strong. So because that's what I need, that the field strong, the strong field. That's only one thing. And if I'm gonna get the strong field, now I need make direction for the fields. If one gonna be clockwise, other gonna be counterclockwise, and gonna be correct Ganses on the system. So I got this interaction between, especially if machines are built with the same manner, with the same sizes, with the same everything, especially when they create like a mirror image of self.
But,
so this is very important.
It's kind of a secret until you're done with it, though, right?
Secret? No, it's not a secret. And let's see.
Because you haven't given us any answers. You just kind of talked in riddles.
No, you got the answer. You got Ganses. You know how to
Yes, we do know how to do all that, but we're asking you specifically how
Well,
you did.
he gave you the answer though, Mark, and you actually have all the clues too, because he gave you the answer in terms of the inner coil is the acidic and the outer is the alkaline. And you've got all your Ganses already lined up with you. That's what you're famous for, Mark, is taking the pH of all your Ganses and everything.
Yeah,
So in a
exactly.
way, you got it all
Yeah,
set up. You just have to select your Ganses according to the pHs and look at it that way to separate them in alkaline and acidic. And maybe you're all set right there. Maybe that's the clue that I see that he gave you anyway. Maybe you're looking
exactly.
for the right recipe when he gave
I'm
you
not looking for
the
that.
way to
I'm
make
just
the
asking.
stew. Pardon me?
All I was asking him was the sequence in which he made that little device, and he sort of hinted at.
Okay, the sequence is. Mhm. Okay, the sequence is pretty basic. When you do the nano coating, I do nano coating with the fire, and after then they go to the caustic soda solution with the steaming condition and stuff like that. So with the fire, no one nano is one option. Before you will nano coat your coil by fire, just spray them with the correct gases. But liquid plasma is a kind of good idea. I was done a few times. Then they actually do very well job.
I understand, Thomas, but what you're saying
But
is
that's the first thing. But that's after fire. After fire, you're okay, and you go to the steaming condition with the caustic soda. So if you like to do just few drops or more CO2 through the caustic soda, or if you like to do some specific condition for your solution,
you put CO2 in your caustic soda when you nano coated some of your rings. Because I did some, what you see in front of you right here, I did some stuff that Armin just told me to do that changed my nano coating completely with some of the 12 salts. So, I mean, we're all experimenting here, and I don't mean to
this is what was I mentioned before. That's the magnesium salt. Those one was made with the magnesium salt. It was small drop magnesium salt inside the solution. That's all. Another other part of solution was very typical for me for maggraph construction. It was some really small, tiny piece of silver, because I like to use these Gans a little bit.
So you put some silver in the Gans too?
Yeah. But really small drop.
We have
was
some
clean.
silver.
Was clean silver, 99.9999%. It's kind of pure silver, but small drop. That's all, and no any other tricks. Just kind of normal solution with one drop of is magnesium salt and a micro chunk of silver. That's all, and that's the main gases, because also. So you got, after then I know I got silver Gans on the coils. So this is my strong alkalic condition. That's how they build. So the next step is normal gases, and I use actually normal gases, CO2, CO, and CH3. Just normally like a one layer top of the code. Like you need to do something like it's one video made by Foundation long time ago, how they actually put the gases on the coil. You just do something like a weak mix, really weak mix. Look like a soup, something like that, and just spray it the coils and don't touch it. Be carefully. So it's normal way. I mean, I didn't make anything special with this. That was only prototype. That's just to check how they're gonna work in normal condition. We don't know any tricks, no any sacrifice and something like that. It's something easy to make, easy to build, and we're gonna check how this works. So the work fantastic, everything is fine, and now I will go with same idea with the reactor inside through these bigger stackers, and let's see what's gonna happen. And maybe if that's the solution, because the Gans is actually very important. The coil is the one thing, but the Gans is actually critical stuff. I think they actually made the field, and if everything gonna be ready, we're gonna check. Maybe I will get my happy field back. I mean, the field was extraordinary. You just feel on your knees like they twisted in the different direction. You're just walking on the floor, like I don't know, like in a space without with different gravitation, and that was really strong feeling, really strong. And also was some like the visibility was different. one thing. It was like in a very delicate frog, something like that.
Excuse me, does this make sense to everybody? Or am I just losing my mind? He feels it in his knees. I understand that, but there's just some basic stuff here that I'm just trying to get across. And then, I mean, the feelings in the soul part, but I'm just, you know, I love you, Thomas, but to get a grip on what you're trying to, you know, present to me here, I still don't understand the sequence in which you Gans, you say, just use the Gans, the normal Gans. What normal Gans? There's.
He told you three times already about the normal Gans. The
Blueprint.
copper oxide, the CO2,
but
and
does he
the
just
CH3.
throw it on the coils, and does it just fall all over the place? And
he told you that he followed the video, the Keshe Foundation video on how to apply it to the coils. Maybe he could give the link to the video. That might help if you really need the details. I'm surprised that you haven't gotten it, Mark. He's been through it a few times. What don't you get about the process?
Well,
is there some magical word that you're still looking for?
Nope, I'm not looking for the magic. I thought I was asking a simple question, but I guess.
Well, he did digress in I think it's just kind of the way that certain cultures talk. They talk around it, and I found, for example, sometimes with an Italian news release compared to English news release, it'll be 3 times longer with lots more words and flourish and going around the subject and then eventually getting to it. It's the way that it sort of goes that way. But I think he sort of covered it a couple of times. Pardon me?
Put the Gans, the sequence of his Ganses on the coil.
Mark, it's not any sequence. Mark, why are you looking for sequence? I didn't say anything about sequence. I say every single coil get one dedicated Gans, mostly. Dedicated Gans, like on the blueprint. If you're gonna look on the blueprint for the Keshe Foundation, blueprint for the Magraph, you got straight. Top coil is a CO2. So you need to make weak soup with small amount of CO2 and liquid plasma CO2. Weak soup, very weak, very like a steam inside. And that's your soup, and you need dip your coil inside the soup, or not even deep, but just put on top of the coil if you're using, I don't know, small devices like that. Very simple solution. Gans inside and just drop top of the coil. Don't touch the coil. That's what your main coil CO2. Middle of the middle is a copper, and on the bottom you got CH3. No any secrets. You got all the videos from the 2 years on the Keshe Foundation website. How to do it.
You guys
easy. No any precision.
Okay, well that actually was more clear, and he said it in 30 seconds what you were asking for a half hour ago. So I guess we had to prod enough to get that out in a concise way. But it was an interesting interchange to get to this point. Yeah, I think that's more direct what you wanted to hear, is it, Mark? What he just said, like you drop it on the coils, and this one and here, and this one here, and that one there, and that would have.
Well, it would be like
the answer.
Like anything, it would be like playing the keys of a piano. If you put CH3 here at a lighter solution and a CO2 there on a heavier, at each point of the coil, that's gonna, like playing the keys of a piano. That's what I was just trying to ask, if that's what, in a sequence, that's what you would do in a laboratory.
I mean, what? I'm not. I'm now on a stage when I actually play that's many things with the Ganses, because for me the most important was for the last 3 months find this field once again, because it was extremely strong. I mean, if someone for you guys get experience with natural medicine, I know it's political incorrectly modern times because everything is illegal. Instead of psilocybin, ayahuasca, LSD and all the stuff, the real medicine. That's how I call it. Maybe it's not correct politically, but anyway, if you know the sensation when your soul cross your physical boundary, that was basically this kind of effect. We actually create sort of field, and with the visual effects, there was kind of steam on the earth, very delicate. You just feel, you just see the kind of everything is different around. You feel a different gravitation for all this field. You walk, when you walk, you got different feeling. You just lighter, and it was pretty much spectacular. You think a little bit lighter way if you're inside the field, and you're happy, and everything is fine. It's like a condition for the spaceship inside, basically. It looks like that, and the target was very basic. The check what is responsible for made this field with the solid state condition, because we didn't use any rotating spinning reactors, anything like that. So, but we're looking for this field by solid state. So idea was different, was basic. Just build the stackers and normal stackers without any experiment. Just try and play with normal average stuff what we got, because this field is somewhere inside. We just need to find a way how to pick up this field. And the solution, and because the first stacker will be actually made with my mate here, the first one who actually made this feeling, this field, was packed full of different solution, different experiments and stuff like that. So, and that was problem, because after this effect, we actually don't know what actually caused this effect, because there was few different solutions inside the stacker, and we actually deconstruct all the situation to the bottom, to the pieces, and build once again. So they take some extra time to check what's gonna happen if I, for example, if I gonna put capacitors on the top, because the first idea was split the capacitors, the plus go at the top, the minus go on the middle. We actually do some effects to create really interesting field, because you just drag the field across the stacker and you just speed up the field. That's the one thing, but actually was not that critical point. The next test was different combination of gases, what we got on the previous stacker, but not that was not the point too. I mean this way. And now when I got Reactor, so was quick decisions. So it's the right time to build two twins. One is a mirror picture for another. And when I got this mirror field, when I got this two mirrors machine, the field's always going to be between. So that's the points, and that's when I like to check in the next week. I need extra, maybe 2-3 weeks to actually nanocode this stuff, because they need to good nanocode. So, and that's the ongoing experiment. I show you how they look inside, because that's the sorry, not stable. That's as you see, that's on the middle. That's connection through the reactor. So, and I'm boiling now a little bit, because I feel I should do the double core reactor. But next version, we're gonna check everything on the stackers, and after, and if everything gonna be fine, the next one gonna be double core reactor inside, and maybe that's the solution for the solid states. So let's see. I'm also very interested how they're gonna behave inside the electric circuit in a house in terms of reductions and fields and all the things. So let's see what's gonna happen. That's the kind of ongoing experiment here.
Thank you. Very nice work.
Well, Thomas, I know that Mark had asked an earlier question, so I want to keep this in mind. These the battery capacitors that you made, these are the same ones that you showed about 2 to 3 weeks ago.
Yeah, pretty much. Yeah. I mean, yes and yes and no.
So you've upgraded a little bit.
Yes.
And Mark, I think you would find these capacitors quite interesting. Thomas, do you still have time to draw those up for us?
Yeah, I don't. I just need to.
Is that all right, Rick?
For you guys.
You want to see something I know I like Thomas's drawing, so I'm always into that.
All right, guys, give me a second. I find a cable and connect my drawing devices. Right. It's always messy, like middle of the laboratory. All right.
Yeah, Mark, Thomas's battery capacitors, they're a little bit unique in the fact that they put a lot more space in between the center core.
And that's the one thing. And the next I try always match few different functionality inside one device, which is important for me. But normally you need to use the capacitor, battery, like a separate element. They're always gonna cause you extra material, extra, copper wire, extra gravitational element, basically. So the concept is straight. Shave all these gravitational elements from the system, just extremely take them out. No any gravitational elements inside the system. That's the main idea. If something gravitational element that's supposed to be designed by me.
You lost me there. You spoke too fast for my slow tongue.
Yeah, is your iPad still trying to come through, Thomas?
All right.
No, it's just that he's a fast talker, and that's good.
All right. Sorry about
There
it.
it goes.
No,
Okay.
it's no problem. It was my problem.
Yeah, actually, Thomas, some people have asked if you could speak a little slower for
All
us,
right.
for some humans to catch up.
All right.
Thank
I
you.
will do it. Thank you. Bad habit. Okay. Always when I play with these capacitors, with these batteries, I always look for a moment when I don't use too much matter. I try shave everything for these heavy gravitational elements. So the less elements inside the stacker, the less elements inside the capacitor, battery, whatever, the less is more. So because the field is stronger, because obvious thing, I don't need to fit all these gravitational elements by gravitational field inside the machine. So the concept is basic. You take all these gravitational elements out and separate them, separate device to help them build field.
Are you drawing something or? Oh, not yet.
Yeah.
Okay. There.
All right. Okay. That's all right. So the main. Let's use the first. Let's start from start. Okay, that's us core. I use a different course. I will draw for a few seconds. This is the tube, basically. It's like an arm connection. If you use arm connection like a rod inside your capacitor is fine. That's the point. And okay, that's the first layer, because I use double layering, triple layering, few different ideas, and that's gonna be a layer, kind of Picasso style. All right, and the third one. It's like let's say star formation idea, basically. Okay. And that's my into the system. That's the first level, first bonding. This is my core, and this is my outside part. Let's say coil, and that's the direction. Normally, when you get direction for the system, because I use in a different way. Normally, many people actually finish the capacitor here. They just close them here, and that's all. But I use in a different way. That's my in. Oops. That's my in through the system, and that's my out from the system. This sort of way. So I got another in through the system, and this is my capacitor. So, and between the core and the capacitor, always, and let's say, what's the correct English name for this part of capacitor? I always lost with this. I call them coil, top of the rod. It's probably some specific name, but I never know. Okay, the first thing is a Gans. That's the Gans with the paper. That's the main interaction layer. That's how you build the first interaction. So after then, you get element, and this is a very interesting thing. And if you like build battery, you just need apply. For example, I don't know, titanium. In my example is the titanium. This is the titanium sheet, like aluminum foil, like whatever you're gonna use. And this is just a few different options for the situation. So that's my ganses on the paper. So, and as you see, this is the first layer. Normally, many people finish on this. They do capacitor like or battery like that. They just do core, some paper with Gans, optionally some aluminum foil, and the top elements. I mean, the coil, top of the core. So, but what's gonna happen if you're gonna bind your coil and back again through the system, go this direction and go this direction. So you got 3 independent floors. Every single floor create interaction, every single one. So between those elements, you get capacitor, because there's no any material with different potential. So this is the only copper wires. So here is only capacitor, but situation go to change if you go to one floor down once, and you here, especially here, you get battery. So, and you got this conjunction between the battery and the capacitor on the top. Another thing, this is the way how you're gonna binding the coil top of the rod. So the one solution is going to be very symbolic sketch. If you get 3 layers, is one option make every single layer with the same direction. So you get quite huge flow, and they quite speed. You actually work with speed, and they quite fast or something like that. This is the different type of battery of capacitors. But what's going to happen if you're going to turn this direction, the opposite direction? So you get your interaction straight in the middle inside the capacitor. And this is a very sensitive part, because it's actually is bound in the same direction, because it's the same piece of wire. You didn't, you're physically unable to, to do opposite direction, like a fully opposite direction, because this is one piece of wire, and you just continue the movement. And when you continue the movement on this direction, you create something like a spark gap between the between 2 layers. So let's go on bottom downstairs. Okay, and if it's this direction, those go those direction, we get this interaction. Actually, we got sort of interaction. So that's the symbolic for the field, symbol for the field. So because the most important and interesting things happen actually in this area, because when field is on the way back, they cause like a strong interaction between the layers. This is same story like 2 stackers. The one is clockwise, other is counterclockwise. Same situation, but the same with the plasma field. The field is absolutely the same. Everything is the same. Environment is absolutely same. There's no any difference. They stay in the same room, for example, but they create this interaction between. So I basically close the interaction inside the capacitor. The idea comes from I don't know. I was mentioned before. Maybe not. The idea comes from Kelvin water dropper generator. You probably know this idea very well, because What's
Say it
Kelvin? Kelvin water dropper generator. Because what does this gentleman do? This gentleman takes two containers with the water. Let's say this is the water. They create something like a copper ring, and they put some like a small stream of water from these containers across the middle of the middle of these rings. So the rings are connected to the floor, and now you get your electric spark between the two rings. So because you create different flow, I mean, physically the direction is absolutely the same, nothing changed. The water still go same direction, but with this ring, the water create one type of flow, with other create other type of flow. And when they go on the bottom, you get copper plate on the bottom, you create electric currents. So that's the Kelvin water dropper generator. So basic ideas, yeah. So let's rotate this idea on the 90 degree, and you got here, you got in, you got your water drop, because that's your water. That's your water, that's your, and only one thing what you need, take them out. This is the same situation like a reverse, across. This is your across, and back again. So this is the water dropper. And those capacitors, battery capacitors, because you got the battery element here. This is the battery. They create all these extra things. And those one is a capacitor, but they always will work in conjunction because it's one whole unit, and always create the independent field, I mean, like a device. That was the main idea from those capacitors. And it's one very interesting concept. Okay, when you got the core, let's see, that's the core. That's the first element. The second, because I use elements, yeah, like as you see on the video, it's like a few elements. It's not only one. Oops. Okay, and we got the 4 elements. Let's say 4 battery capacitors on one rod, on one core. This is one core and 4 devices on the top. Okay, quicker, sorry. All right. And let's draw how the system works. This is my in through the system, and this is my out. And this is my in. And for example, but guys, you need to check 3 different combinations. In my combination, that's the blue line is like minus, it's in electricity, and plus is outside. So the signal go here, back again, and this is the end. I just do something like let's compression or decompression, because depends how you're gonna connect the signal. If you're gonna go to the top layer and everything gonna traveling through the core, you actually compress all the signal. If you go this way, you actually expand the signal. So there's a few different idea from connection. I use them both. Actually, with those capacitors, I use extension basically to everything go here. I like to build kind of shielding around the capacitor, because Mr. Machran mentioned many times to try the closed capacitor and made something like a field for device. So they close them in a box with, especially with the box after Ganses, which is a very good idea. So because they create different environment and machines start work much more better. So sometimes, not always. I didn't check every time, but yeah, that's true. If you're gonna cover up your maggraph with a plastic box when you before made, for example, a CH3, your efficiency gonna be bigger, gonna be higher, and your reduction gonna be higher. And you see this how they behave, because you actually create something like a shield around the device, and they actually work better inside the shield, because this is the plasma environment and everything work better. So that's the first things when I do. And next I go to the bottom and do same thing, and go to the bottom and go to same thing, and always is sort of extension idea. I just try extend the field, go them out. Okay, and the next, okay, and the finish. So that's the basic connection between the four different capacitors. So now I need to create battery, but that's my experiment for now. The battery is only on the middle. That's the observation of human body, because my belly didn't start in my mouth. If I will start do all the stuff here, when field is a little bit different, that would be probably situation like trying put too much outside. So the good idea for now, for me, I was gonna check how work, because it's the very first stuff. I didn't check it correctly, but if you get some battery, the battery is inside. So everything is, let's say, close inside a specific environment. That's the magnetic environment. I just try basically build something like a same thing like a star formation, but inside the capacitors, inside the batteries. So that's my, let's say, inner situation. Where's the heavy one? All right. And that's my titanium, for example, or aluminum, or whatever you like. That's my copper element, increasing, everything go out. So this field here is a capacitor. So this field inside is a battery, because natural, because that's the construction of this elements. So, and one field is close inside other field. So that's the point for that's the idea how to mesh together functionality for the capacitor and functionality for the battery inside one device. And also when you got two, you get really nice interaction, because it's like a fully working reactor inside the capacitor. Because remember, in my case, the core is empty inside. It's like a tunnel. That's something like that. This is my core. And it's completely empty inside. So I got all the plasma flow, which is coming this way, because we always got both fields. But inside we got something like an extra field. It's like a Russian babushka, one inside another, inside another, inside another. So if I'm gonna change the properties from one of those babushka inside, so I got reactor inside with the different properties, because that's the battery. So if I got different properties here, I got different properties here. I also create another shielding. And this is the basic concept for my capacitors. But I don't know, guys, you got it, because it's kind of messy drawing on the screen. I think the idea is pretty much easy.
Yeah, I think you delivered that pretty clearly. Anybody have any questions on
yes.
that part?
Mr. Denning has some questions, but very few. the only question I really have is when this is one section of your battery capacitor. You seem to have two of these and they fit inside each other. How does that work?
Two sections. I mean, all right. I think okay, because a kind of important thing for me is built. When I create something, I'm looking for balance. For the interaction comes from balance, the good balance, the good interaction. It's like a relationship, I think. same parallel. So let's draw the capacitor. They connect like a series actually, because okay, this one, this two. All right, it's gonna be very simple. Let's do it this way.
Before you go ahead with that, I just want to say it's amazing constructions, lovely creations. I'm really delightful to look at them. It's really good. It's nice to listen to you. It's just really nice. Thank you.
Oh, thank you, sir. All right.
There are a couple of questions on the live stream about exactly how you made your coils and so on. CA says, I've tried to, he has a question about the capacitors. I have tried to copy them, but mine don't look that nice. What is the tip to get them nicely on top of each other? And does he use a special tube to roll the copper wire on top of each other? What is the production method? Mine look like a thick, ugly bunch of wires on top of each other.
My first 12 or something like that look pretty much the same. It was disaster.
I was going to suggest that it's the same way, that the same method that you get to Carnegie Hall, which is practice, practice, practice.
Exactly.
So maybe that would apply, I guess. But it's true with bending copper wire. I've done a copper wire bending in the past for different projects, and it takes some time to develop the skill to get it to bend exactly the way you want to. And you can try different techniques using various tubes and whatever you have handy that can wrap around in a smooth way.
Exactly. I mean, no other special tools. The one thing is important. I mean, it's patient. That's the most important thing. No any tools. If you got your piece of pipe when you use to bounding the coils, just cut them to the, I don't know, maybe 1.5 centimeters. I don't know how much they're gonna be in inches. Something like, I don't know, maybe 7-6 inches, something like that. Something handy to keep in your hand, and do maneuver in every single position. That's very important, because if you got the long pipe and you try create this capacitor using this long pipe, it's disaster. It's really unfriendly. Just cut them to the, I don't know, maybe 6 inch and we'll be fine. Maybe 5 inch, even better. Small metal pipe in your hand and copper wire, and just a little bit patient. They need some patience. And don't use the drill, don't use any electric device, do by hands. Because if you don't get practice with this electric stuff, you're never gonna do it. This is the problem when you need to turn this middle layer on a reverse direction. And also because that's when I show you guys, this is the specific capacitor with this Kelvin, Lord Kelvin idea with the water dropper, but it's not a big deal. Actually create the capacitor with the 3 different floors, battery with the 3 different floors with the same direction. It's not any problem. You just need bind the different way. You just need back again and once again. It's kind of practition, just practice. I got some video. I will send some links because I was, my friends done some video for this. Okay, let's back to the story. So that's that's only testing now. That's quite interesting thing for me, and work very well. I get I don't ask maybe for some people going to be spectacular reduction for the electricity consumption at home if you connect your maggraph to your electric system, because those type of battery capacitor do fantastic job. I got reports from people 80-90% reduction, so which is quite huge, and not after 5, 6 or 10 months, but after 2-3 months, which is really fast. And that's one of the interesting thing with these capacitors, because I check all this stuff in a practical condition, in a real world. It's not the story about theory and build a theory about the theory about the theory and create something like I don't know, imaginary world. Things was actually, when I'm looking for the practical solution and something would work very well with stackers, with maggraphs and stuff like that. So something was able to use on a practical matter.
Please go ahead, show us. That's very nice.
So that's my in, and that's what I do now. The in is like a tree. You get only one core, one main core. This is my tunnel, arm-on connection. That's a genius idea. And that's my, okay, that's my plus, and that's my minus. And this is the, as you see, guys, this is the, do something like that. This is the 1 unit. This is, let's say, this is funny thing, because this is one capacitor, one battery of capacitor, but it's not the one, because got 4 sections. And this is very interesting thing to test. If you like to test, I really recommend to you. If you like disconnect everything or made everything from one piece of wire. I done few experiments. Now I testing the capacitor, all this part made by one piece of wire, like that, because we start from the bottom. Reverse.
Have you made it?
Okay, I start on the bottom.
Great idea. It's an amazing idea. Very good.
Yeah, everything is
made it, man.
Everything is working condition. Is probably, I know, maybe 12, maybe 15 maggraphs with this solution already working. Here in London is few, and they do really solid reduction for power consumption at homes and nice fields, and people feel very well. Anyway, they already check. Anyway, I go on the bottom, a kind of specific way to draw this. Sorry, guys, because I need to correct one thing. Okay, it's going to be messy. The better option is without mess. All right.
Well, this is like a step-up transformator.
Exactly, pretty much, because the idea, we're not that's all original. We just need to observe reality and adopt these things who actually work in a plasma condition, because everything is a plasma condition. Okay, and from the top of the bottom.
Well, you're totally right, because it doesn't matter whatever it is. It works whatever it is, the condition. Yes, it. Okay. Sorry, go ahead.
Mm-hmm. This is my direction. The direction always go there from. Not always, because whatever you like to do, I just checking few different options. That's my favorite now. Favor connection. Okay, go from the top and up, and when you go from the outside ring, go out to the system, and that's connection to the maggraph. All right, and the maggraph back to the system. So go maggraph. So, and this is the next bank of battery of capacitors. So this is the one section, and this is another section. But with this section, I got this funky thing. I got the battery on the middle, which actually helped me, because I've got interesting observation about how sometimes if you get heavy load for the very fresh maggraph, how they able to hit the system, and what is the problem with the system, how to eliminate all the heatings problem, all kind of, I don't know, places when you get, let's say, traffic jam inside the system. So that's the idea how to. That's one of those how to eliminate this traffic jam with the plasma fields. So and same story here, because it's like always like a mirror image of self. This is same battery on the middle, but all these elements, all this whole unit is like a whole unit. But the whole unit contain 1, 2, 3, 4, 5 elements, which four elements are two elements are capacitor working in conjunction with the battery inside. So let's say we got something like an X structure with the yoke inside. So same story here.
Yeah.
And but what I do is actually quite. I know we need to check this probably more deeply. Anyway, the reverse situation. So the core go to. I just reverse the core and the coils on the capacitor. So that's the different story. And my out is and this is and how to actually because to is one thing more. I don't like you guys to leave you with this mistake. Okay. This is quite because we got direction from the top to the bottom or reverse. Always we got two options. And the option here is I go from the bottom.
Yes.
Just extraction the field. Extract. Yeah. So the two fields extract and they create something like our interaction between. So the interaction happen bottom of the stacker, as you mentioned, I always joking, my electric system, my electronics, because I always call the capacitors electronics, the Magrath electronics. This electronic system is always on the bottom when it's very strong stream from the Magrath. It's very strong field. And they work inside this field, and for a long time for me was problem how to actually catch this point. Maybe I put too close, maybe they too far, maybe they interrupt the field from the coils, and all this sort of ideas. And after then I was start do this sort of solution, and they actually start work together very well. So they create this field because when you get your Magrath, signal from the Magrath go in the middle and so on. You get this two capacitors on the bottom. If you're going to draw with sort of kind of 3D. This is the Magrath, and this is the battery. So I get flow from the Magrath, come between this between these capacitor batteries. So that was the idea. And the extraction, all right, and the signal go out here.
Yes.
So this is basic idea of how to keep the balance inside the system. And sometimes I get problem with too big overload, but it's not the problem with the machines. It's sometimes when I do experiment, I just push machine to the extreme boundaries with some, I don't know, big load, like maybe 10 kilowatts, maybe 15 kilowatts, something like that, quite heavy load.
Yeah.
Industrial way. I just spot few places when system like to hit itself, when it's fresh, when it's unready yet, when fields builds itself. So I try work with the specific points, and for me is I was mentioning before this thing. This is the wait a moment. Here, this is the 2 points here. On this.
So when were you planning on sharing all this?
Oh, he did this one other time. He did this a couple of weeks ago, 3 weeks ago.
Yeah,
and
I know. The cheeky one, isn't it?
The different guys, and that's why, because I mean, maybe yes, maybe not. I don't know. We need to check. But for now, I think the difference always living in some really small spaces. I mean, the small difference do big thing, the small difference. And the small difference was actually this element. Normally, I was put all the shielding for the battery across all the rods. So it was like that, was across the 4 elements, across the 4 capacitors. So now I just made it smaller. I just close everything inside like that. So now on the end, I get capacitors. So they're more sensitive and they get bigger ability to actually send the kind of subtle, delicate interaction through the core. So they the signal don't shoot stuck on them. Because sometimes I get feeling if you get battery, the signal like to stuck somewhere in the battery and create something like extra motion conjunction, sometimes called heating. So that was the main idea, to actually made it smaller. The battery inside, battery go inside. It's like a human construction. I mean, we got battery inside. So this is the skin outside, all the inside parts inside. Simple parallel. I always look for extreme simple parallel.
I can see the rib cage there with the coils around and the spinal column in the middle.
Exactly, and this is the head. This is the maggraph. This is the brain.
Yeah.
And that's the legs. The legs, this is the electric system. This is the gravitational elements. That's the reason why we got, like Mr. Mahan mentioned, the fingers shorter on the feet. That's the reason.
Okay, well, I still have one question before you get too far out here. Your center reactor that sits inside your stacker unit, where do those wires connect to?
To wires.
They come off of your center reactor, the one that has the resin in it.
All right. Okay. All right. Give me seconds. All right. I need the right color for the reactor. That's gonna be my reactor. Kind of Picasso syndrome. All right, and this is my reactor, and reactor is connected through the blue line. For now, with this stuff when I get now on my desk, this is the blue line. This is the reactor, because the coils, the maggraph, that's the maggraph. The maggraph is a red, the boys is a blue, something like that. So the maggraph gonna be plus, the reactor is a minus. Just for now, but actually ideal option is actually create both plus and minus, but that's gonna be next version of solid state reactor. How to actually minimize everything and do extra reactor inside the reactor, something like a fractal design. Everything smaller, one inside another, and the interaction outside, they actually start to grow enormously. So that's the main idea for this solution.
Well, I'll be looking forward to that. I'm also looking forward to your health projects, see how you progress there as well.
I'm still working and try to finish the system, because now I got these 2 maggraphs to finish and some extra maggraphs with some another experiments. I think in the next 2 or 3 weeks the medical system will be ready, something like that. Yeah, no more 3 weeks, something like that. I need the 3 weeks to finish.
I think my project's going to take me all summer. My particular project that I'm doing, I think, is going to take me all summer. I've got time restraints, and I also have financial restraints. There's a certain amount of money I can allocate each month, and it's going to take it's going to take several months to get where I want to go.
But finally should be done. I mean, I hope I will finish faster this medical project,
Well,
maybe in the next week. So let's see, because that's only story with the time. I just need to finish the capacitors, actually, exactly capacitors, because that's what I do for this medical system. We done with we actually done because I get some friends, and you know, we work like a team sometimes, and not some we actually work like a collective, and everyone do independent research, and we share this information with each other. Anyway, because I've got these batteries, this capacitor batteries with this construction. When you go to one layer, when you back again, go to another layer, when you get three different layers, and this interaction between the layers. So I was build the prototype using the same idea, the battery, same convention, but I was use my concept from the construction, the capacitor from the help system, the big one.
I think your volume broke up there for a moment. I think your audio broke up. Can you restate that?
Okay, I think I'm all right now. Test. Should be fine.
Yes, very good.
Okay. And I was designing the battery through the medical system using actually the same concept with the bonding, when you with the three different layers and with this opposite direction on the middle. And we actually set up the system. Is actually but it's in Poland. It's not in England here. And that's when I know the system works very well, and signal inside this health unit is extremely strong. It's very, very strong. So that's look like a really nice possibility to kind of extra bits to make system stronger. That's all. The medical system, because you know the solution is inside. It's not outside. It's not the way how many turns you're gonna do, how big they're gonna be, or left or right. It doesn't matter. The trick is inside. This small interaction between this one layer who actually is on the way back. This third lever. I say the second lever on the middle when it's turned back. So they go and they go out. Something like that. Sorry. Go this way. And the interaction between this like a small plasma spark gap they create, and I think it's quite a big amount of plasma energy, and they work fantastic like a support for the big health station. And we already got one big health station with these batteries, and that's look like it's a fully working, fantastic working solution. So I will actually do the same batteries from the system now, because I got few different ideas. I will check these ideas, and not everything make me happy. And finally, I will start with this concept to actually use this solution with a reactor inside to the medical system, and let's see what's going to happen. I mean, it should be quick. I mean, I said 3 weeks because I got other things to do. That's only one problem. I like to finish everything in the right time. That's only one limitation, the 24 hours. And if everything will be fine, maybe in the next 2 weeks, the system will be ready, because everything is done apart of capacitors. I just need to build these capacitors. That's the easy thing to do. I think, I don't know, maybe 2 days and everything gonna be done. So and after then I get 2 weeks or something like that, nano coating. That's the most time consuming process. Because I mean, when you start to do these capacitors, and after few when they look dodgy, after after I don't know, 25 gonna be fine. Maybe not the first 10 capacitors, but the 25 should be perfect. We should practice something.
I'm gonna bring you back to your drawing just one more time.
Mm-hmm.
So the very bottom capacitor where the wire comes off, you give it a point with an arrow. Where does that particular wire going to go?
This wire?
Yes.
This wire, because I didn't mention, that's your electric leads, because I connect everything to the electric supply. Everything, this is my minus, sorry, I didn't mention. All right. This is my minus, and this is my plus. And this line is like a. And I need to do probably something like.
Is this similar to what you're doing with your car stuff?
Yes. Okay. Now you're gonna get it. Now everything is clear. That's your electric supply. That's your load. That's your system. All right. Be more straight.
The blue is part of your out?
Yeah.
On this bottom, I mean?
Yeah. That's
The ground circuit, right?
Yeah. I mean, I do different thing with the ground. I just connect ground. I will show you guys like a separate line. That's my kind of dodgy experiments with the British electric system. Let's see what's gonna happen next. Maybe I'm gonna blow up some electric station. I don't know. Maybe not. Better than not.
So I asked you just a moment ago about, is this similar to your car system?
Yes, yeah. The idea is pretty much same. It's absolutely same. But if you like to do some experiment, because as you see, this system work reverse. If you like, for example, check opposite direction when you get two same capacitors, I mean same thing connected in the same direction, so that's gonna be plus, not the minus. Try. It's feel very interesting option inside the system, because I'm just trying. Now the next is actually something what I do now. I just sitting with Alex Beats, because this is the very interesting thing, and there's a lot of interesting solution inside, and I just try match all this idea with some of my concept, and find maybe I will find some connection, and maybe I will extend one of my concept. Maybe they're gonna be disaster, maybe not. Let's see what's gonna happen, because inside Alex Beast mentioned one important thing: the flow for the magnetic and the gravitational. He actually separate this flow in a fantastic way, and that's why I'm looking for this type of small capacitors and batteries. How to actually using really small amount of copper. You don't need buying tons of copper. You just need buying one small funky battery capacitor. And if that's going to be possible, this can make something who actually turn your system to off-grid system, because we actually on this narrow edge to build self-sufficient off-grid system. And
right after the off-grid system. Yes, you were really excited when you made the smaller maggrav that you only needed one capacitor. Was it a half of this half system?
Okay, the small one is a few purpose. One purpose, small amount of copper. The next purpose, checking how behave the field with the fractal environment. Excuse me. I don't know how to say because
Rick, you've got to shut me up when you you'll have to guard against me. I'll keep going.
We are coming up on 5.5 hours here now, and it's 3 a.m. But that's okay. We're on a bit of a roll, so go with it here, and we'll probably wrap up fairly soon. We'll just keep that in mind.
Yeah, I will try to be quick. Sorry for the sound. I was too late. So.
Don't speak too quick, because people start complaining about that. Just
Please
keep calm and clear and just concise. You're doing good. Thank you, Thomas.
All right, thank you. Okay, that's my reactor. That's my crazy coils. Looks like that, and that's going to be my system. So the first, I need to draw the line from my electric supply. The first line gonna be in, out, and the hot line. That's actually very interesting observation when I got with this one capacitor. This is battery capacitor. It's not only capacitor. This is the 3 layers inside and battery capacitor. He don't like heat itself, even with huge load. I mean, for now, I didn't put him to the boundary, but looks like it's a very winning construction. Okay. And I need this capacitor. All right.
Thomas, very impressive, man. It's honestly, it's a great presentation. All the bits that you have talked about made sense, and the bits that didn't will all discover. But your presentation is very good, as long as you speak slightly slower. Your knowledge is unquestionable. No one can say anything about it. Just you have to know that. So we're sharing all that. It's amazing, and thank you so much. I mean,
thank you, sir.
Expanded a lot, honestly. But bear in mind, please, sir, speak slowly. That makes much more sense than ever. Even a little information makes a bigger sense to people who listen to you. And
all right, I'll be a little bit slow.
Thank you.
All right. Welcome. All right, this is my the small one, the small capacitor, but is made different way because I didn't actually always some mistakes. All right, no mistakes. Okay, because it's only one side. It's like a flower. It's built like a flower, like a plant. I didn't put the signal here. It's not any connection here. The signal only here to through the core, and the core is finished and it's done. It's all. It's like a flower basically. That's the simple parallel. And the core is connected through the reactor. This in this manner, and other part of capacitor, because that's the battery inside. Is everything is connected same actually way. Way out. Wait a moment. I mentioned this out. Okay, so the construction is like flower. Maybe I should rotate because this looks like let's see, basically flower. Okay, that's my insight. Is I like connection with the nature. This is my blue line. This is my hotline, and the hotline is connected to the sun. In my case, the sun are coils, and now as you see, it's a few different options. If you like, think about the system like about the nature. It's always few different ideas. So for me, for this actually experiment was actually connection like that. So I create something like a flower, and the flower gets artificial sun, and the sun create energy from the flower. Let's say something like that.
Okay,
that's all.
good.
There's only one capacitor working outside. That's all. I get something.
Do you have a working model of it?
Yeah, exactly. I show you guys something because I got something
Just
interesting.
just a minute, just a minute, just a minute, just a minute.
Yep.
He showed us that working model earlier, but here's when you say you're making it like a flower, are those coils that you have around there a single group of coils, or did you do like you did the other way and have three, one going
This
one?
is
What I'm trying to
okay.
say.
That's okay. That's one piece of copper. All these elements. This is one piece of copper, and this one, the rod, is the next one. I just try to use less copper.
You didn't.
More.
You didn't bring the coils back on top of each other like you did in the other.
No. This is only one. This is only one chunk, like this small one. I show you guys something.
What you were delighted that it worked, and so that's why I wanted to go back over it.
Yeah, I mean the really interesting thing, because it was very fresh. I was set up machine. I was set up this mini maggraph. I called it mini. The mini start work, and everything was fine. It was fantastic. And I decided, okay, let's go for 500 watts. Let's put some more serious loads through the system. And fun enough, always when I connect, I mean not always, but sometimes when you connect the heavy loads for start, because that was like, I don't know, the first 24 hours, I didn't actually do anything special with the stack. I just put together and connect them to the heavy load. No any heating, no any problems, nothing like that. No any shutting fuses and no hot cables. Perfect. One capacitor, and that's basically capacitor, and that was really kind of astonishing. Like, wow, maybe that's the way.
So you can't beat my memory here. On the unit you showed, you had a little ball that was coming off of the end. Was it coming off of the stamen of this flower?
Yeah, this is like let's say it's like a wireless. It's like a parallel situation. That's going to be quicker option. Okay, you got your coils.
Well,
all right, coils, and is us. Is the sun inside, okay, and we got capacitor. So the connection is quite simple. Capacitor go like that. Let's say, let's draw like a circle. Gonna be much more easy to catch the points. And
yes, you did have it like a
my
circle.
coils are, you see, my coils are red. So, and the next element, I do, this is my core inside, and this is the blue element. So is actually the prototype. I was actually connecting the opposite way, because I should connect in the opposite way, because as you see, this is the leakage with the interaction, because everything goes straight. But I was trying to build some like a monofield. So because normally when you got the better option, gonna be opposite connection, the reverse connection. When you got the something that's very important. It's not like normally. I mean, as you see, the core should be on a plus, like coils. If you like to build something like a huge interaction inside the stacker, so maybe I will gonna reconstruct and connect once again in a different way. But that was this experiment, how to actually match together these two elements with the same idea. That was the start. So let's see what's going to happen next, because the idea for the next one is when I get my coils. Once again, very quick. My coils and sun side. So the coils always go, in this case, through the plus. All right, and this is my capacitor. So I actually create opposite situation, and the core should be plus, and outside should be minus, same way. And now I got quite strong field inside a small stacker, because this is the mono field. We have no any interaction inside, because there's no any interaction. This is like a one field, like a monomagnets, and this is like a two magnets, and that one play with another one, and they create this interaction in the middle. So anyway, that's another idea how to actually build all this stuff and create a monofield, create multiple fields, and sort of on things. So there's a few opportunities. It's nothing write on stone. It's many options. I show very quick the last thing. Actually switch to the camera on my mobile device. All right. This is quite funky capacitor. All right.
I think you're going to have to stop share
Yeah.
in order to do that.
Okay. All right. And that's the correct version. As the final stage. That was supposed to should be with this small maggraph, but I was impatient and like always. So as you see, guys, you probably understood this idea very well now. It's a simple thing. They work on the opposite way. The core inside one is a plus, and inside another one is a minus. This is like two batteries working with the conjunction. Something like that. Unconnected yet. Gonna be some experiments.
Oh, that's right. You do you put the titanium in there, or do you put your
Titanium?
Yeah.
So
that'd be interesting to see it hooked up, sort of like a crystal radio. We hook an antenna up in the ground and
yeah, exactly. Yeah.
listen to it and see what it sounds like.
Pretty much.
Yeah, you actually could. You think about it, you've got all the components of a crystal radio built into a capacitor like that, because you not only have the capacitor and the induction coil and the battery, which you don't even need a battery in a crystal radio, by the way, but you got a battery, which really is a valuable addition, because it acts as an amplifier and a power source and whatnot. And you also have resistance, which is important.
No
And
picture,
you
no
also,
picture, Rick. No picture, Rick. I have to help you out there.
Okay, because it won't show up in the...
It's even
just a minute.
Even worse.
I'm just about to deliver my punchline here.
I know it. I wrote it.
It's even worse.
And let me finish. And you have actually a diode. That's the part you forgot, is the diode part. There's a one-way circuitry through that mechanism as well. And that's the key to the crystal radio, to the crystal radio like this, and to the brain power device, and to all the other crystal radios of the world, is that tiny little 1N34A diode only allows the flow one way. And it turns the the AC into a DC that we can hear in headphones and whatnot. So that's the difference here. That's what's so critical. You got all the components of a crystal radio. It just needs to be tuned and listened to. So you could actually literally, like I did with this crystal radio, which initially didn't have the tail on it or the tuner. It was just but it did have a circuit inside, but it was designed as a meditative device, and so on. It's tuned to the Schumann frequency. But I decided to add the tail onto it and actually listen to it, listen to what the crystal radio has to say, you might say. by just plugging it into my computer, running it through some different sound software to alter the pitch frequencies and whatnot. And bingo, you could hear virtually everything around that has any kind of field on it. So I think that your device could act, it's already acting as a radio. It's already a receiver of broad spectrum probably, but it might have specific things that it's picking up that this kind of crystal radio can't pick up because of all the nanomaterials, the plasma, the interaction of everything. But all the components point to having, well, the essential things in a crystal radio are actually only the diode, and basically you could get away with a diode, an antenna, and a ground. You don't even need those entirely. And the rest of it is almost arbitrary because it still acts as a resonating circuit. It's putting in the inductor and the capacitance that increases the sensitivity and makes it able to have selectivity as well. Those are the two criteria, sensitivity and selectivity. So by having that just looked beautiful. Those two coils together, it almost had a classic crystal radio kind of look to it in a way. It's just a matter of hooking up an antenna in the ground, putting a little tail on it to plug into your computer, and maybe you could convince it to fly.
I got this crystal radio. Was here for 2 years. I was using them for 2 years. I was build them from scratch and still got somewhere there. It's somewhere there. I still got the original element, the minerals. I forgot the name. The kind of metal shiny pieces was used inside the crystal radio. I already nano-code them. Oh, yeah. So, but for now, yeah, I started thinking. I still thinking about this diode, about create the flow inside the circuit, and that was the reason why I started sitting and spending a lot of time with Alex Beats. Because the one thing when I got here, that's the idea from the capacitors, batteries, and now I would like to extend these things about this, about how to actually using the small pieces, basically like the small capacitors, create something like a powerful circuit who actually is able to bring you off-grid system to your home.
Yep, you could look at for toward power, or the reverse as a super sensitive detector as well. Might be a perfect gravitational field detector, for example, or maybe for detecting events in the on the out in space, essentially. And yeah, it's interesting. Good work there. It's inspiring.
Thank you, sir. So let's see what's gonna happen next. I will do some reports from experiments. So,
yep.
Thank you, guys.
Thank you very much. Thank you.
Thank you to you, sir. It's very, very late at the moment, and thanks so much for everything.
Definitely very late. But I was wondering, trying to get here.
We lost Mark and we lost Lee.
We did lose Mark, didn't we? I think Mark wanted to show something, and we kind of overran him a little bit there. Ran overtime, you might say. It's all good. He'll be back next week, as hope everybody else is. I do need to wrap things up here. It's over 5.5 hours, so we can probably put it off till next week, unless someone has that new spaceship that's levitating they want to show. I could be convinced to stay open another extra half hour. No one's taken me up on that in the last couple of years, but we're getting closer and closer every week, I think.
All right, quickly. I think what is being transferred in terms of using the spaceship or anything is happening in another realm, and there are ways to do in this realm, but what I have experienced is somewhere in between this realm and the other things that where I can add to it, where you feel dizzy and you feel on your eyes go. It's like you're fainting and kind of feeling where you like to travel to another realm or another place. Would that be ever going to be a material, like one step you're here, one step you're there? Is that going to be like this, or how is it going to be? That's just what I wanted to add in the last minute. And if I've said something wrong, sorry. But I had to do that. Like, yeah, after all this.
Well, I think there's lots of ways to travel, and with the physicality is only one of them, and probably a pretty primitive way when it comes right down to it. So the more we learn, the more we progress, the more we'll find out, and the more interesting it gets in many ways, because we're very limited by the the whole thing of moving our physicality around. I thought of it today. It's like when I was traveling behind this very slow driver at 5 or 10 kilometers under our very low speed limits, which is 50k here, and they're doing about 40k, and I'm almost falling asleep. I'm in that dreamy state that you're just mentioning, sort of. And I'm thinking, whoa, in the old days, they would have been, walking this same trail in this rural area 100 years ago or whatever. And then I'm imagining, well, they had to, got to have the horse and buggy sort of deal. You have this thing that would bounce you around, and you'd have the horse pulling you. And I think, whoa, that must have been so boring, so slow. But then I thought, wait a minute. I flashed back to, I'm on that horse and buggy, going slow, but to me it's like I'm going so fast, man. I used to walk this trail. It took 2 days. Now I can do it in 1 day in this horse and buggy. It takes me a half hour in my car or whatever. So, and then I'm thinking, well, geez, I'm driving really slow behind this person. What if I had a new Tesla car that can do 0 to 100 kilometers in 2.7 seconds? And I could just go whoosh here, whoosh there, whoosh here, whoosh there. Bingo. And then what if we go beyond that? We're into the space technology and whatnot, and we can go from this part of the planet to the other part of the planet. But yet, it's still not fast enough. It's like, and then finally, I'm projecting into the future. All this is just driving behind this slow person because I'm daydreaming and projecting. I'm thinking, okay, now I'm in the future. The future is, I've got my summer place on Alpha Centauri, and it's taking me over 10 minutes to get there for lunch. And this is ridiculous. There's just so much traffic now. We should demand to be able to get there in less than 3.2 minutes. This is just, it's just such a waste of time. Alpha Centauri been back in 20 minutes, and maybe this is our limitation in our human thinking. It's no matter how fast it is, it'll never be quite fast enough, and will never be, even if it's instant, it'll be. I'm just in one place. I need to be in 8 places at once. So now I got to clone myself and go, so I can do everything instantly all at once instead of just this reality and instantly at this, from one reality to another instantly. We want to be able to go to all realities, or at least ones we select instantly, and live in them all at once. And there's no bounds to man's greed, in a way. But in another way, it's more like expansion or evolution as mankind, to be able to, why not go to Alpha Centauri for lunch and have a summer place there? And
Absolutely,
you know,
absolutely.
I think we got it something like, I mean, not physically yet, but you got Magrav. Many people. If you remember the moment when Magrav start working in your house, your dreams.
Who
I
could
got
say you haven't been there?
many friends who actually report to me the first stamp of Magrav in a house, different dreams, and those dreams. This is your dreams, Rick. This is Alpha Centauri. You have no any traffic jam. So 12 minutes to Alpha Centauri is too long. I didn't get time now, and you're just jumping inside your dreams like that, and many people bring me a lot of stories how they traveling inside dreams. Actually, I do the same thing. I mean, I just
well,
flying
this
across.
is now, yes, it's now becoming more and more prevalent on planet Earth, this idea of remote viewing and remote reading and astral travel and higher bodies and working
You know
with
what?
fields and separations and different levels and dimensions and so on. It's all becoming much more into the mainstream now. And this is becoming, if you think about it, all adds up to becoming more of a telepathic and empathetic population, and that's the way I understand it. Being telepathic is the norm. That's the normal way it is in the universe.
Yeah, absolutely.
And they come to Earth and go, "What? You guys are, you're not able to, connect with each other? This is very strange." And we're all like bound up in our own individual worlds and going about doing our own things and our various activities, and we forget to expand and connect with everything around us, and that they can connect with us. And eventually, if we're all telepathic, then we won't be able to lie to each other, we won't be able to cheat, and we won't be able to hurt each other, because you know that you're hurting yourself when you hurt others, because you'll feel it immediately, you'll know it immediately, the way they do in the rest of the universe. So this is the thing, and in different ways this manifests. It pops up as different things that are happening now, and different stories. Like you say, people have adventures in their dreams, and we learned how to start to control the various factors that are involved to be able to get in touch with these different bodies that we have. Or
Yesterday we got it. I got here very interesting meeting. Was one gentleman who actually visits me, my good friend. He lives outside the London. He just jumped for one day, visit me and see the system, and we done experiment, because this gentleman is quite sensitive. I know that he's. I know it's a name for kind of very sensitive people to do remote viewing and stuff like that. He actually training these things for years, ironically, and he's really good with this remote kind of viewing with the conscious dreaming and stuff like that. And we got very interesting stories today. He got something like a remote viewing inside the system. We just got a lot of fun, because we just asked, okay, go now top of the Europe and check how look the Europe in the next year, or go somewhere and check this, or go somewhere and check this. And it was really interesting, And he got basically straight vision and fully conscious, no any kind of, this, let's say, flying condition. Nothing like that. Completely conscious gentleman speaking with you with no any problem, but at same moment, same time, he got sort of vision in a remote viewing with what's gonna happen.
What are they?
There, what's gonna happen there inside the system. We just check the system in this purpose, and what was fantastic. This reality comics, they come, Rick. I think we're very close. If the things like that happen, so soon we started flying to the stars, to the other places in space, on demand.
Right. So even if your maggrav isn't giving you all the benefits for electricity savings and so on, it could be actually altering one's life in very profound ways that might only show up later. So it's interesting.
Yeah, I mean,
It's,
mostly the people after when they spot first reduction, like a 50%, they completely forgot about all the story with the electricity and is completely unimportant. They always say, electricity, not important, not important. Even electricity is not important. I will tell you my last dream. And
yeah,
that's the
right.
thing.
Chinese call it, or one group called it the happy box, because it made people happy when they came into the room where the magrev was sitting. So interesting.
So we got spectacular, hugely visible evolution for humankind. For someone who was only oriented to materialistic part, like electricity bills, which is important for us life too. I mean, that's not how we need to pay this stuff. Is important, but this is like an evolution from bills to dreams, and from dreams to the space, and I love it.
Very
This
good.
really smooth evolution. No any jumps on the road. No any higher cliffs when you need to jump. Nothing like that. Everything happens spontaneously in a natural way, with the natural flow, with your own timing, because everyone get different. Everyone is different, and everyone.
So are you going to use all your creations, all the coils you made? Wonderful to look at them, to put them all together and create this synchronization. And it's like,
Let's see what's going to happen with these two stackers.
come on, man, show us something. Show like do something and put them all together. Wonderful. It's just like unbelievable constructions. We haven't come to that point because we're digging into deeper levels of it. But where you go beyond that, it's just you have created something's really nice. I mean, I'd love to look at them, but I'd love to know.
Okay, I'm gonna give you
Get
answer.
it? You see?
I'm gonna give you answer. The system here is specific. I didn't show all the stuff what I got here.
Yeah, I know.
And the system is really specific. You just need these few places inside the system. I need to connect system in a specific way. I'm gonna put you on the chair and I'm gonna give you maybe 3, maybe 5 minutes, and you're gonna close your eyes and you're gonna flying to whatever you like. The last time I was trying my favorite thing. Okay, my favorite stuff. This is the flying top of the savannah in Africa. The last time I was just flying, it was amazing feeling. I was like I don't know, maybe 100 meter top of the ground, maybe 30 meters, maybe 100, just like flying top of the ground, and just trace. I was trace the animals who just run like a big stud of kudu or gazelle or something like that on a savannah, and that was so spectacular and so realistic. I just take it fly top of the savannah and watch wild nature, and seriously looks much better than BBC try showing.
Yeah, we could have maggrav safaris. I could see that now, you know.
Exactly. And
get in my chamber, I go to this part of the world or some other world. Yeah.
Now,
this is this is very good. This is using visualization and so
goes
on.
so easy if you got strong system and everything is correct. I don't know, is connect correct here.
Well, part of it is your brain and your essential self and so on have to be connected and ready and believe in it and all kinds of stuff like that. That's transferable with the technology, because the technology helps people get into that state, but they still have to know what to do with it. It's not like you just close your eyes and it'll instantly happen necessarily to everyone. It'll have to take some training probably beforehand, some initiation, you might say, and just prepare people a certain way that try this and to make sure they're calm or have some sort of preparation beforehand, let's say.
I mean, the first what you see inside the system, you see something like a Space Odyssey credits, like lights, but blurred, not that sharp like in a Kubrick movie, but blurred, like flying across the space with a really high speed, and everything is almost blurred, and that's how things started. And actually, mostly 90% people who actually try the system, this my system, report me same things. They just start to see the lights. You get close eyes, but you very easily see all the lights, sparks, and things like that. So the next things, the people with the close eyes, they able to, let's say, take off out of body journey and see self from outside and see the room from outside, which is quite interesting. Things like that happen. And the most funny thing, and the most funky, I think, no one, I mean, apart of two, maybe three gentlemen who was with training with this kind of things, because they do this for years by self with conscious dreaming and stuff like that. But other people, they didn't get any single training. They just normal average people like everyone on the street. They just come straight through the system, sit down, close the eyes, and wow, I see the lights. Wow, I'm flying, something like that. I think this is part of my explanation is this is part of ourselves. We don't need to learn how to do it. This is like a kid's born.
Cool.
This is normal state. We just only forgot everything. That's the only one
Right.
problem. Now
It's
we
like
just,
having flying dreams when you're young was easy, but we forgot how to do that because it was trained out of us by conditioning and whatnot.
yeah. For example, guys, did you remember your last dream? And try to remember yourself when you walk inside the dream. You're walking. You're gonna probably get very fast, very interesting discovery. You never walk. Only you maybe sometimes touch the ground in your dreams. In us dreams, we never walk. This is us natural condition. Actually, when we walk, we didn't walk because the construction of us body show straight. We actually levitate. The us knees is not constructed to walking. If you start walking, we probably because that's the construction of muscles and legs and stuff like that. They physically unable to hold this body. We probably after 3 steps we probably fall down completely, and physically it's impossible walking if you for creatures built like a human. If you don't levitate, we actually levitate, but we still levitate with this conjunction with the gravitational field. We still use the earth. So inside the dreams we don't need it. Inside the systems we don't need it. And I think this is some kind of natural evolution, and this is the good thing, because that means no one needs to spend hours to learn how to manage all these things, because this is the moment where you need to wake up kids inside yourself and try and remind yourself all the story when you was really, really small kids, and there was no any boundary, was no any limitation.
Or you could spend 30 years with meditation. That works.
Yeah, that's true. People, I really recommend to meditation inside the system. This is something.
Yeah, it seems like a good combination for any kind of activity like that.
Okay, we should back. Yeah, go ahead and end it. I was just going to say to Thomas that I'm thinking about that reactor he has, and when he's going to put in another reactor inside that reactor. What's he thinking about when he does that? So I'll catch him on another flip-flop. Thanks, Rick.
I'm sure we're going to hear lots more from Thomas. We haven't picked his brain completely yet, but he's emptied out a lot here tonight. That was really good. I loved your diagrams, especially Thomas. They're very clear and easy to understand as we go through and so on. So thank you for that.
I got something for you guys, but not today, because
a teaser. Okay.
Yeah, sorry about this.
This is just like the Batman and Robin series. This is great.
Yeah. See you next week.
Yes. Next time.
And this is the story you was talking about the last week. I was sleepy. I didn't join you guys. Sorry about that. I got amazing dreams anyway. And you was mentioning, guys, about the different way to do Gans, especially with the plasma condition. I was made these things because I was do Ganses using the plasma for almost now, actually for start, when I start actually work with the blueprint, that was one of the first ideas, how to actually use the plasma environment, not any electric supply, no, something like an opposite way, just. But I think it's gonna be the good story for the next week. I'll show
So,
Okay.
so what are you saying, that you make plasma now without, so how are you making your plasma?
It's a leading question.
No, I'm just gonna, I don't need you to tell me. I'm just saying you have made it the way you wanted to make it, or you're designing a new way of making it?
I think it's not. It's difficult to say it's a new way because it's different. In general, it's difficult to say something like I was discover something, I was create, because everything when I do.
No, that's not what I was saying.
I'm not father.
For you specifically, you have for yourself.
Yeah. This is different. I mean, pretty much similar, but you actually prepare the box and all this environment to make gases a little bit different way. You just use the plasma field, and everything happen. I mean, say elements, same piece of copper inside the salt water and a piece of zinc, if you like, or other materials. The principles are the same. It's not any difference at all. But the difference is the environment and all the, let's say, shielding around your box when you do the ganses. And the ganses behave very well. We check these ganses with the maggraph system because if something was probably failed or was wrong, we would never see electric reduction on electric power reduction, because that's the functionality will come from the ganses, the combination of ganses. So the field is fine because we got reduction, the Gans works, that's the real Gans, everything is fine. So I show you in the next week how I do all these things. They need patience, they need time. It's not the method to do something fast and quick, absolutely. But in other way, this is the method how to actually speed up Ganses by self-thinking. Very interesting. This is your interaction with the box is definitely stronger, and because the environment when I built around the box create this bridge between you and your box much more stronger than normally when you walk around the typical box with the tiles.
When you use your water in your bucket, in your box, the water you put in your box.
Yeah, I will show you. No, the trick is much more easy.
No, I said when you do that, but you do put water in your box, don't you?
Yeah.
Okay.
I use the water. I was already trying without no any water. We had dry condition, works same, because we got the environment, we got the fields, and the fields actually create the dances.
Yeah, I tried that with my mind, but I still came up empty there for a while. But
you know what?
I'm kind of thinking that there's something in there, but I don't know what it is. I can't see it yet. It's like when
you see
Columbus. Go ahead.
Danny, you see this? Check your dust. Check your dust around the boxes. I'm seriously, I'm not joking. Check your dust around the boxes. It's not normal. That's not normal dust. Part of this dust does the ganses, especially if you got maggraph system at home. Check around the box. If you got some dust on your desk when you got the box with the ganses, check. They behave different. The normal dust is different. This dust behave a little bit different. The grammature, the texture is a little bit different. The answer is very straight and basic. That's your ganses in environmental condition, let's say.
Entirely possible. We should leave that for a topic for next week, guys. I'm gonna have to wrap it up.
Thank you for your patience. Thank you for your patience.
4 a.m. I'm gonna work today, so I'm gonna have to wrap things up.
Good night.
Thank you, Denny, for those additional questions, and thank you, Thomas, for continuing to give us some great stuff there. And look forward to more next week. And we'll try to fit Mark in and others. And great show. Thanks, everybody. Wonderful. Okay, so I'm going to wrap it up for Keshe Plasma Reactor Group for what's now is Wednesday, March 15th, 2017. Okay, bye everybody, and stay tuned next week for the next episode. Okay, you in the live stream for another question gets asked here. Love it. Thanks, guys.